I would like to have some give you some announcement also. Like actually, Lini ma'am has told me to announce that the valediction will be at sharp 1 o'clock. So all the centers accordingly, please arrange. Once see around 12:45, I'll be finishing it, and then we'll have a question and answer session. So at around 1 o'clock, I think all will be ready. So 1 o'clock sharp, we will be starting with the valediction. So all the nodal centers, the coordinators, please note down the valediction will be at sharp 1 o'clock. Okay, so if there are participants sitting, please announce to your, just inform to your coordinators also to be ready for the valediction at sharp 1. So I am Shimi, I'm assistant professor here in the electrical engineering department, and mainly my area of interest is power electronics and drives. Then I do like MATLAB, Simulink, LabVIEW, and hardware interface also. Like we have number of projects here in our laboratory where we have power electronic based devices connected to the like real-time interface is being done using different hardwares. Like we have worked with Adreno, we have worked with DSpace, we have worked with FPGA boards, Xilinx and even Quartz. So these are some of the hardwares which can be connected, and now we are in the process of getting Opal RT. So once that comes, even high speed interface can be done, real time interface can be done with that. So today the task which is given to me is like the 4 days what you saw is you saw about neural network, you saw about fuzzy logic, then you saw PSO, GA and all optimization technique. So the main task today what is given to me is to how to implement or bring them to the Simulink environment. Because in Simulink environment, the real-time interface, say when you want to connect a DSpace or when you want to connect an Adreno or when you want to connect an Opal RT, all these things, in Simulink it is, you have some features which is very simple. You have to just drag and drop the blocks, you have to connect them and you can bring into reality. So the main thing is when you want to connect it, like it is not only in the Simulink environment, even in the coding environment, MATLAB coding environment also you can connect the hardware, but the Simulink environment is still easy to do it. And as we all know, when we do coding, it is like we find little difficulty, like once we writing the logic and all those things is little difficult, but in Simulink environment it is little easy because there are only just blocks. You can just drag the blocks and you can connect them and you can get your real-time system. So there, when you want to implement artificial intelligence or when you want to have optimization into it, the Simulink environment is a very easy environment which can easily be linked with the hardware. So now we just go into, like I'm just opening the MATLAB. So here today first like around 1 o'clock till 1 I have the lecture. So first we will see how to have neural network into Simulink. So you would have seen the neural network toolbox. So how to bring that toolbox into the Simulink environment. And after bringing into the Simulink environment, in the next, like after the T session, I'll be just showing you how to bring it, like using DSpace, how to implement it in real time. So first of all, that neural network block sets, how will we use it, or where to use it and how to bring it into Simulink. That will be the first thing which we'll be seeing. So now I think all of you can see my MATLAB window, and now first we want to implement neural network. So before that, like I'll just give you a small presentation on Simulink. So I'm just, with a small example we will start, because going into Simulink also will be difficult in the initial stage. So I'm just going to take a small example of a power electronics example itself. We have a multi-level inverter here. You can just see a multi-level inverter. So this inverter, okay, we have simulated in MATLAB also. There, how can we use this neural network? Neural network. or even I can tell you how to use a GA or PSO. All those things also, how to connect it. So first of all, we'll understand the concept of this system. Then we will go into MATLAB environment. Okay, I think you can understand. First, we will see what is this. So here you can see a multi-level inverter. So multi-level inverter in the sense, you can see here there is a DC input. Here one of the DC input is here, another DC, here another DC. So there are 5 DC sources. So since there are 5 DC sources, this is a 11 level inverter. So this is a 11 level. So here this is a 11 level inverter, and this 5 DC is converted into a AC. You can see here that AC is, but otherwise this AC is in the form of a step. You can see here the AC output which you got is in the form of steps here. So the first DC, it is giving here this output, and when 2 are cascaded, you get this output. So similarly you get a step. So our main problem in this, when you convert DC to AC, the main problem what you face is harmonics are introduced, because here you can see the output which is not a pure sine wave. You should get a sine wave like this, is it? But this is not a pure sine wave, the one which we got. So it has number of harmonics in it. Okay, so this harmonics we have to eliminate. That is our main problem. So once again I'll just tell, this problem is a simple problem for explaining neural network and all the GA or PSO, like different concepts where to apply, that I have taken. It may be your own problem. Okay, you can just think you may be working in power system, or you may be working in any other area. All those areas can be brought into Simulink. So you need not worry about the example which I have taken. The example which I have taken here is just to explain the concept, how to bring all these blocks into Simulink. Okay, so now again you can see here, so we have multi-level inverter, you have number of DC inputs, and the output what we want is AC. But in this AC system, the problem is harmonics are there. So what will we do? How will we remove these harmonics? So for that, these are the equations. You can see the Fourier equation is written at the top. The output voltage which I showed you there. The last thing, the step voltage what you have got here can be written in this form. So the omega t is equal to sigma, n is equal to 1, 3, 5, because here the fundamental is there, that is the first, then the third harmonics, fifth harmonics, all those things are present. So that overall equation can be written in this form. And here the modulation index. So MI, modulation index, you can say rearrange this and write, say this 4 by n pi, you just bring it down. And this VDC1, VDC2, VDC3, VDC4 and VDC5, that also you can bring it to the left side. So you will get that sigma VDCM, that is the DC values. So you can see here, this is the VDC1, this is VDC2, this is VDC3, this is VDC4 and this is VDC5. So these parameters, when you bring it down here, this is the sigma term. Sigma VDC is this term. And the fundamental, this is the fundamental voltage. So that fundamental voltage is this V1, and this 4 by pi also I have brought it. So here this is my modulation index. Okay, so the modulation index, if you see, modulation index, this modulation index is nothing but the fundamental voltage divided by all the DC components. Okay, so now what is my problem? I have to eliminate my harmonics. So now I have to write my equations. Any system, you have to first write the equations. For that, what I am doing, I am just writing my first equation. What I want my fundamental. So this is my fundamental equation which I want. So I have written VDC1 is VDC1 cos alpha 1 plus VDC2 cos alpha 2 plus VDC3 cos alpha 3 plus VDC4 cos alpha 4 plus VDC5 cos alpha 5 is equal to my modulation index. That is my fundamental which I require. What are the things which I don't require? I don't require my harmonics. I don't want my third harmonics. I don't want my fifth harmonics. I don't want my seventh harmonics. I don't want my ninth harmonics, 11, 13, all these harmonics I don't want. Even harmonics, already it will get cancelled, so we need not worry about the even harmonics. So which are the harmonics I have to get, which are the harmonics which I want to eliminate? This method is said to be the selective harmonic elimination. I am selecting which are the harmonics I want to eliminate and I am eliminating it. Can you understand? I am selecting it and I am eliminating it. That's why the name itself is selective harmonic elimination technique. So here I have not taken my third harmonics, or I have not taken my ninth harmonics. What is the reason? I don't want that. The thing is, this system here I showed you single phase. If it is a three-phase system, just think if it is a three-phase system, the triplets will automatically get cancelled. Say 3, so 9 and all those things are not going to come. So when I am using a method and say, you know how many unknowns are here? My alpha 1 is an unknown, alpha 2 is an unknown, alpha 3 is an unknown, alpha 4 is an unknown, and alpha 5 is an unknown. 5 unknown parameters are there. Okay, this mi, say I can just fix it. My modulation index, I know the fundamental voltage which I want, and if I know all the DC inputs, I can fix this modulation index. It may be 0 to 1, it may be 0.1, 0.2, 0.3, I can have any values. This modulation index may be my 0.1 or it may be my 0.2. So different values I can have it here. My modulation index, I can vary it. So when I write a program, what I can do? Mi value I can vary, I can keep it as 0.1. I'll solve for alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5. Then I'll keep it as 0.2. Then I'll solve for alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5. So if there are 5 unknowns, how many equations I require? To solve, I require 5 equations. So you can see here, I have 5 equations. This is 1, 2, 3, 4 and 5 equations I have. Now I have to choose which are the harmonics which I want to eliminate, because there can be only 5. There are 5 unknowns, there can be only 5 equations. So which are the one I want to eliminate? I can, if it is a single phase system, say if it is a single phase system, I can even take my third harmonics. If it is a single phase system, here instead of 5, instead of this 13, I can take this 3 and I can eliminate this 13. Because deadliest harmonics are the lower order harmonics. Is it? But here I have considered these equations for a 3-phase system. So I have not considered my third harmonics. I have considered my 5th, 7, 11 and 13, and I have to put them equal to 0. Because I want to make those harmonics equal to 0. Can you get it? So now this is okay. Now these equations, how will I solve? It is not an easy method to solve this. These are transcendental equations. These are a little tough to solve. These transcendental equations I can solve using different numerical analysis methods. You have the Newton-Raphson, you have Gauss-Seidel, all those methods you can use and you can solve, or you can solve using optimization technique. You can find the optimal angles at which the THD will be minimum. So what are the optimal angles, alpha 1, alpha 2? How will you find? You can use particle swarm optimization. You have already learned, I think, that particle swarm optimization also sir would have come and taught you. So GA you can use PSO, you can use any ant colony algorithm, anything you use and solve these equations. Okay, so when you are using, say, if you want to use GA or something, GA or PSO, what is required? Objective functions. You will be defining. For my problem, which I showed you here, my objective function is, I want to eliminate my THD. Like say my THD, total harmonic distortion, you can see here, in this case, my THD should be 0. Total harmonics, if it is 0, it is better. Or according to IEEE standard, it should be less than or equal to 5%. According to IEEE, it should be less than or equal to 5%. Sorry. Okay, so my main aim is to bring this below 5%. That is my main aim. So for that, I have to write my objective function. So how will I write my objective function? So according to this objective function is my THD. So that THD is equal to 100 into root of this F2 squared. F2 squared is nothing but the 5th harmonic. That we have to make it 0, is it? So that square plus this F3 function, 7th, my 11th harmonics, F4 function, and my 13th harmonics is my 5th function. This modulus of all these things divided by my fundamental will be my objective function. Okay, so what problem should I take here? Is it a maximization problem or a minimization problem? Minimization, is it? I have to make this function minimum. In the sense it should come almost to 0 so that my harmonics are eliminated. So okay, so solving these equations you can do using GA. For GA and PSO, this will be my objective function. This objective function I will be considering as a minimal function, and I will be solving it to get my answers alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5. Or what you can do, you can also use Newton-Raphson or any other numerical techniques to solve these equations. So for that place you need not have objective function. Directly you can solve using different, like Newton-Raphson. You have to see what are the steps. You have to have a J matrix, okay, Jordan's matrix you will be finding, and you will be solving. So you can have different methods and find this alpha 1, alpha 2, alpha 3 and 4. So some problems there will be constraints also. So in my problem here, my constraint is the alpha 1 should be greater than 0, but it should not be less than alpha 2. My alpha 2 should be greater than alpha 1, it should not be less than alpha 3. My alpha 3 should be greater than alpha 2, but it should not be less than alpha 4. How did we get this constraint? So this is my problem. Here you can see, if this is my initial point, this is alpha 1. This one is my alpha 1, or this theta 1 which is given here. And you can see that this theta 1 should be greater than 0, but it should be less than this value. Which is this value? This one is my theta 2. So it should be greater than alpha 1 but less than theta 2. And what is my third angle here? You can see this from here. This is the angle. This is nothing but my theta 3. So my theta 2 should be greater than theta 1, but it should be less than theta 3. Well, how should my theta 3 be? It should be greater than theta 2, but less than theta 4. How should my theta 4 be? Greater than theta 3, but less than theta 4. And all these values should be less than 90 degrees. Okay, theta 1, theta 2. So for your problem also, whenever you take your problem, just see what are the equations required, and every problem will have some constraint. The output which you are going to get, okay, the output here, in this problem, the angles are my output. And those angles, we should know that what is the range of those angles. How should this theta 2 be? How should this theta 3 be? This is a must. You have to understand your problem clearly, then you have to go to the next step. It's not that you have just chosen the problem and you want to use neural network, you want to use fuzzy logic. It is not that. You have to first know what are the inputs, what are their ranges, and what are the constraints. This is a must. Then only you can solve the problem. So in this problem, we have seen that my objective function is also there. I have to solve, and I think sir would have told you how to solve the steps to solve these things. And number of toolboxes are also available. You can just go to MATLAB file exchange. Those who are new to this MATLAB, you can just go to Google and search for MATLAB file exchange. There you go and search for PSO toolbox, GA toolbox. Toolboxes are there. Even programs are available. PSO programs are available. Those programs, it is, say, any objective function you give it to that program, it will solve and give you the answer. Okay, all those methods, the method is same, is it? You have some birds, they are going to fly, they will change their position depending on their own position and their neighbor's position. All these things are known. So they have written some program commonly. The thing is, what is the birds, like the objective function is our main thing there. That according to our problem, we will choose our objective function, write the program for that, go and embed in your toolbox. That will run the answer, and it will give you the answer for alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5 for different modulation index. Can you get this problem? So now I'll be showing you the MATLAB, like we will do it in Simulink. So here you can see, this is my these are my 5 H bridges which I showed you initially, and here I have connected the PV, photovoltaic arrays. Okay, so DC, or you can have DC inputs here, any battery source. You can even have capacitors. Capacitors also can be connected here. So any DC source, which I showed you in the first slide. So these are the DC sources, and these are my inverters. For these I have to give what I have to give as input? The firing angles, is it? So this will be my alpha 1. So this will be my alpha 2. So similarly, these are my different alpha values, alpha 3, alpha 4 and alpha 5. Okay, is it clear? So this we will be, just when we do it you will understand. So now I have found, as I already told you, using different methods I have found out the angles, and I can just show you the angles. So for neural network, and when you want to do it in ANFIS, what you have to do, you have to store those values in Excel. Okay, so here say what I've done, when you want to do it in neural network, you keep the inputs and outputs in separate files. Say neural network, NN input I have. There's a small problem with directly opening it, so I'm just opening through direct. So neural network, I have just stored the data in NN input, like you can keep it in any location. I have my data here, I'm just searching for it. Say my NN input is this. So these are my modulation index. So 0.5, I'm changing the modulation index from 0.5 till 0.95, because till 1 it don't go. Those who know power electronics, you may know it, because firing angle till 180 degrees or 0 firing is not possible. Always you give a dead band there. So modulation index also till 1 you don't take, always we will be taking it till 0.95. Okay, so that's why modulation index till this I have taken, and I have started from 0.05. You can even have it in column form. You can have it in the row form or column. This Excel sheet we have to bring it. Similarly, I want my second data, that is my output, MATLAB NN output. So this is my NN output, and my 5 angles. These angles are in radians. Okay, so you can see the angles here. These angles 0.6 to 0.8, 0.9, the ones which you're seeing here on the screen, these are in radians. So here, for the same corresponding modulation index, I have taken the data for all the angles. So I think now you understood. We had a multi-level inverter. Our problem was we have to find out the 5 angles for each H bridge such that my THD is 0. So what I did, I wrote my equations, and those equations I solved using any method, Newton-Raphson or GA or PS, or any method I solved. I found my optimal angles, and my optimal angles, I have a set of angles now. Now what I'm doing, my input is modulation index and my output are my firing angles. So I have taken both of them, I have kept it in 2 separate files now. Now I have to implement it in MATLAB. So to implement in MATLAB, ma'am, I have already told you neural network, she has already taught you, and she would have shown you the toolbox also. Okay. So now that same toolbox for Simulink, you have another one called the NN start. Just give the command NN start. Okay. So you have a fitting tool here. NN start, if you give, you have a fitting tool. Go to that fitting tool and just click on it. ये क्या करें, ये एक्चुअली ना, ये whenever I connect this projector, ये स्क्रीन ऊपर चले जाता है. दोनों नीचे, मुझे नीचे करना है, वो आइकॉन्स दिख नहीं रहे. ये रिमूव कर दिया तो आ जाता है, बट उसके लिए क्या रेजोल्यूशन चेंज करके देखो. ओके, डिस्प्ले सेटिंग जाके चेंज करना ना. क्या करूं, इतना करूं? या ओके, फिर भी थोड़ा और भी रेजोल्यूशन इंक्रीज कर देती. बाकी आप लोगों के लिए कुछ प्रॉब्लम नहीं होगा ना रेजोल्यूशन चेंज करने से? सेम थिंग ओनली इज कमिंग. एनीवे दिस विंडो इज देयर, ऊपर का नहीं दिख रहा है. वो क्लोज करने के वो भी नहीं आ रहे. दैट्स अ प्रॉब्लम. एक्चुअली ना, ये मैंने एनी टाइम व्हेन आई कनेक्ट दिस थिंग ऐसे होता है, ऊपर का दिख नहीं रहे. एक बार ऐसे आया था, किसी ने मुझे वो करके दिया, बट पता नहीं वो कैसे हुआ. ये विंडो है ये. इसका साइज कुछ चेंज कम कर सकते हैं. ये विंडो है, इसका साइज मुझे कम करना है. ओके, फिर मैं इसके साथ ही ट्राई करूंगी.
फंक्शन वो होता है ना, डिस्प्ले वाला फंक्शन है F4.
डिस्प्ले में यहाँ खुला है. ये जाके रेजोल्यूशन चेंज कर दिया था. Okay, ma'am. It's so. So this window, so you got this window. So this is the neural network fitness tool. So how did I open it? Once again, I'll just show you. First, I gave NN start. I just clicked. So this fitting tool will come. Okay, there you have pattern recognition, clustering tool, and all those things. You can try that also. So first, click on this fitting tool. So this window will open. This is the fitting tool window, and here you can see this is the yes.
Hello.
Yeah,
Ma'am, actually the earlier resolution was much better visible.
Okay. Actually, wait one second. I'll do it. I'll do it. Okay, first you go for NN start. Okay. So in NN start, now I think you can see the neural network start window. You have the fitting tool, getting started wizard. If you go, you have the fitting tool there. So in this fitting tool, you have to just click on this fitting tool. Okay, just click on this fitting tool. And here This window will open. This is a welcome to neural network fitting tool window, and you have here the neural network layers. So here this is a 2-layer feed forward network with sigmoidal hidden layers, and you can see here the hidden layers also. You can just go and choose how many hidden layers you want, the weight bias and all these things. It is given here, and you have the input, you have the hidden layers, output layers, and the output here. So here you have a next button. You have to just go and click on this next button. Okay, I'll change the resolution for the centers now, because this tool, it is very difficult to get the full window. That's why we have changed the resolution. Once this is over, we will again go to the same resolution. I'll just expand and I'll show it to you. So now the thing is, now you have this window, and you can see here inputs you have to give it here, the inputs, and the outputs you have to give here. So for inputs, I already showed you the Excel file. Okay, Excel file you have already seen the input we have saved. Same Excel file we have to call here. So the input, I am just clicking on the input data, and I am just going and choosing the Excel file which I showed you. So NN input. So you can see here, this is my NN input. I am just choosing that and open. So it is getting open. So once it is okay, it will come in the Excel sheet. Okay, so you can see the preview also. So it is coming now. So here, now you can see the import wizard. These are the data. Okay, so the data has come in the sheet. Now I have to just click next. So I didn't do anything difficult. What I did, I had my data in Excel sheet, NN input, NN output. Now I started NN start. I went to the fitting tool. I am just selecting my input data and output data. So here if you see, the name comes as data. Always it takes data. So next for output also it will take data. So you will get a problem there, because input and output same, it will be overridden. So what you have to write, you have to change this data name. Go and click on here, click on this and rename it as NN start or anything. Sorry, this is NN input. You can give so you can give any name. So NN input I have given, I have just clicked on it, so I can see the data here. Just click finish. So your data will come here. Say NN input has come here. You can see the NN input, and this side you can see 451 samples and 1 element. So there are 451 samples what I have taken, and there is 1 element. When you keep it as a column, I showed you in NN input, I had a row there. Do you remember the data which I showed you was in row? If you have it in column, here it will come as like 1 sample and 451 elements. So in that case, what you have to do, change the columns and rows. So you have to be very careful whether the samples here we know that my only one element is modulation index. I had only one modulation index. Do you remember that? Only one element was my input. So here it is correct now. One element is input and there are 451 samples. If you keep the data in the form of column, it will come reverse here. It will come as one sample and 451 elements. So you know that is wrong. So you can just go and change this matrix to row. Say now you change like this, you will get one sample and 451 elements. This is not our thing. We want it as column. Okay, so now I got it as 451 samples and one element. This you have to be careful, because if you do it wrong, your answer also will go wrong there. So next is I want my output. Okay, so here I have to go and import my output. So here again I am going to my data. And I am just selecting my data. NN output, just click OK. So it is just loading the data. So any data which you have, you can just load it. One thing you have to remember is The number of input data and output data should be same. So you had like say 451 samples, the output should also be 451. Then only it will be matching. Is that input and output should be same? So that also you have to see when you're bringing the data. You are just say if you have a lot of data and you have reduced the number of data, see that the input and output should be same. So here again I'm just giving next, and here as I already told you again the name will be data. Here you keep it data also not a problem, because the other input you have given another name. So anyway I'll change it. I will keep it as NN output. Okay, so now I'm giving finish. I think you can see this window here. This is the input wizard window, and I'm just giving finish. So my output is also here. So those who are doing it for the first time, if you don't have data, you can load data from example also. So load example data, if you give number of data they have given there. Okay, those data first time when you're trying, if you don't have data, you can try from there. So now you have to go to the next. Here you can see next, go next. So this window will open. This window is opening, and here you can see that validation and test data. So the data which you have given, that 451 samples, it automatically takes 70% of the data for training. That is 315 samples it has taken for training. For validation, 15% of the data, that is 68 samples it has taken for validation, and for testing 15%. If you feel I don't want validation 15, you can just go and change the data also. So automatically training, so how much you want, you can change it. Okay, so here you can change how much data you want for training, how much data you want for validation, you can change it. Let me keep it as 15. I'm just taking the default. Okay, default, and here you can see what is training, validation and testing. You can just go and read it. So this is what we have taken. 315 samples we have taken for training, 68 samples for validation, and 68 samples for testing. Again you can go next. So in the next window, here the number of hidden layers. Here you can give the number of hidden layers. Actually this window is little cut, but you can just try it in the lab. It will be coming as a full window. So number of hidden layers, if you want, you can go and change the number also. So automatically here also it will change. So by default they have given 10 hidden layers. If you want, you can change accordingly. So here you can see we have given one input. This is one input, and there are 5 outputs. Because I think you remember modulation index was my input, and my 5 firing angles, alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5 are my 5 firing angles here. Okay, so next we have to go next. So again you can see here a training icon is here. So it uses back propagation algorithm for training, Levenberg. So you just give the train. So automatically the toolbox which ma'am would have shown you, that comes and it will train the data. And here you can see the mean square error, the regression, all these datas will be coming here. Okay, so the plots also will come. So you have the error histogram. This is the error histogram, the 0 error, and the training data, the validation and the testing errors are here. Similarly, you can go and see the plot fit. So this is the fitting output, like so the error is this orange color. So you can see the error in orange, and the other testing output data, the test target, all these datas are plotted here. Okay, so these datas are here. This is your and next is regression plot. That window is also not coming down. Anyway, you can just see this regression plot. So it will show you the fit and all the data, how it is fitted. The blue line, which will be in the center. The blue line is here. You can see the center line and how the data is fit in that. Okay, so this is your regression plot. So now You have done the training. You want to retrain, you can retrain also. Go to the next. So in the next, again, if you have some more data, what you can do again, you can load them and train it again. Okay, or you want to adjust the network size and all those things, you can again do it. When you do it in the lab, just try all those things. So this till now, what we have done, we have taken the data and we have trained it. Go to the next step. So the next step, here you can go and get the script also. You have the advanced script and the simple script. If you go and give the script, the whole script will also come. Here, if you want to go and change the methods, like say how many samples you want to change the samples, or the method at which you're solving, all these things you can go and change it here. Okay, the train command, everything is there. So in the code is also available. You can just change the code according to your requirement and you can run it. Or now our main aim was to bring into Simulink. Is it? We want to bring it into the Simulink environment. So I'm just giving you the thing. Just Simulink diagram, you click, the Simulink window will open, and that will give you the Simulink model of the data which I have trained now. So it will take little time. So the Simulink window will open. It will be a whole subsystem will be there. So we have to go into the subsystem and take our model. So here in this model, we saw that we had 10 hidden layers. So there also you can see there will be 10 weights, like 10 hidden layers are there. So different layers and all those things you can see in your Simulink window. And that Simulink, what you can do, your real-time model, whatever you have made. Now I showed you the first, when I started with a multi-level inverter. So I'll show you how to take this block into your multi-level inverter and run it. So that will be the thing. It will take little time. It's generating the Simulink diagram here. You can see it will take little time, and once you get it, you can take that to your window. So same way, we will be next seeing the ANFIS also. So in adaptive neurofuzzy also, same way you have a toolbox where you can have the Simulink output, you can bring it, and that Simulink output, again you can take it to your model. So first thing what you have to do is, whichever field you are working, just make the Simulink model of your system. It may be a IEEE bus, it may be your power electronic circuit where you have inverters, or it may be a fax device or anything, wind turbines. All those models are also available in Simulink. I'll be just showing you that. So here you can see this is the Simulink model. Here one, and like you can see, one input and only one output, but actually we have 5 outputs here. So we have to just change our model accordingly. So here you can see, just go click, right click, and look under mask. So the Simulink window which is coming, just right click on it and go to look under mask. So this is the different layers what you get. So what you can do is, you can just open a new window and take this. So here we have how many input? Only one input. So I am just, before that I'll just delete my output, and I want 5 outputs. Is it? So depending on your system, say you have 10 outputs, you have to have a mux there and you have to divide that data. So I'm just opening the library, commonly used block. I have my, so I want demux because I am splitting the data. So here there are 5 datas coming and I want 5. So number of output port is 5. Apply. Okay. Okay. So input also I'm just deleting it. And I'm making a subsystem of this. I think I'm a little fast. Like just I've deleted my input and output. Just select all the things which you want. Right click and create subsystem. So this is your subsystem which you can take it to your model. So if this is my model, I can just go and copy it. Anyway, this is not required here. Here itself we have made the model. So this is my neural network model. You can have it, and one input, and I'll take 5 outputs. And you can go and mask it if you want some image on it, change the color, all those things you can do. So now you double click on it, this window will open. Okay, and here you can just go and see, this is the general structure. You have the weights, the bias, and all the other elements, and here you can just go and click. So there are 10 hidden layers. So all these layers, 10 hidden layers, you can see all the layers are formed, and the weight also, depending on your data, it will automatically give select the weights. You need not go and choose your weights. Okay, it will give bias also, bias data and the weight data, it will choose accordingly. You can just go and see the other parameters also. Here this is a mux. Okay, so here you have the sigmoidal function and all the ports. It will be discussed, and the bias value also, depending on the number 10 layers, it will automatically give you the different values. Okay, so now we have done with this. We have formed a model. This model we have to go and implement in our work. So I have my multi-level inverter. I can just show you that. So let me open my MDL file. So this you can see here, a window. Okay, so here this is the motor, this is my multi-level inverter. Okay, so I'm just looking under mask. So this is the multi-level inverter which I showed you there. So these are my 5 firing angles. Okay, these are my 5 firing angles, and here I have connected a PV array. You can have battery or any system, and here, since this is a 3-phase system, the angles are coming here, and these angles 120 degrees shift you have to give. So those things are done here inside this, and 120 degree shift, and again 120 degree shift for R phase, this is A phase, B phase and C phase. So these are my different angles. Okay, so these angles, from where I am getting, this is the modulation index. So I have calculated the modulation index, taking the data here, the voltage here, the frequency and all these things. The modulation index is calculated, and that modulation index is coming here. And what I'm going to do, I am just deleting this, and I am going to put the block which I showed you now, which we made. Inside this. Okay, so we have taken the data, we have trained it. So depending on the modulation index which is coming inside, I have 5 firing angles. So I can show you this. This is the model which we made now, the layers and all those things. I think you remember it. Okay, so these we are giving it the 5 inputs. Okay, I am just closing. So now this is my overall system. I have my multi-level inverter connected to a standalone system. It may be a grid. You can even connect it to the grid or any system. And here now when I run, this should run. Before that I have some masked values. I have to give those. TS control and TS power I have already defined, like they are my sampling times. So I have just taken it. Now I can run this program. Okay, so I think all of you can see the window. So I'm just running this program. So here the neural network which you have done, even the weights, you can optimize the weights. There also PGA PSO can come into picture. Okay, the model which we have made, the neural network, we had the weights there defined, is it? Those weights also you can optimize it. Optimization can be applied there also. I showed you in the firing angle. Okay, you have to just think on which place we can optimize, which are the places where optimization is required, which are the places you have to apply neural network. That you have to think for your problem where to apply. So in this system, if you see what we did, we first of all, our main aim was to reduce the harmonics, so that we wrote the equations. After writing the equations, we solved it. We can solve it using any method, Newton-Raphson, GA, PSO, any method you can solve. This which I showed you now, I have solved it using PSO. Okay, and I got those angles. optimal angles, and those optimal angles I have implemented here using neural network. But here also neural network is not required. In MATLAB you have the lookup table available. So when my data is there, I can give it in the lookup table also. But just to show you a simple example, I have just shown you here neural network. But in your real-time system, neural network can be used in any other place. In this problem, even neural network is not required here. But I just want to take an example where you can have optimization and neural network. That's why I took this example. So you can see the output. You can see the output like the 11 level output here. Okay, I've stopped it and I can just see the output. This is my output. I can just change the color and show you. So you can see here, this is the output. So this is the steps what you can see here. The 11 level. So this is the phase voltage. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 level inverter. You can get 11. And in phase there will be 21. So 22 minus 1, that will be your line volt. Line voltage means you will have 21 steps. So this is what you can get. Okay, so in this system itself you can find the harmonics and all those things. So what is the harmonics using these firing angles? We'll just see here. You can go to the power GUI, which is here. You just double click on it. A window will open. So you can see here, this is the simulation configuration and analysis tools are there. You can go to this FFT analysis toolbox and just click it. So this is your FFT window. So this is the phase voltage and line voltage is. This is your line voltage. Okay, so this line voltage which you can see here, this is your line voltage, so FFT analysis tool, and here you have the starting time, number of cycles, all these things you can choose. So here one cycle, I'm just going to see for one cycle, actually it has not gone till 0.11. Let me keep it as 0.1 or 0.08. Because I didn't run the program fully, so it has stopped here now. So we can have it as 0.08. So 0.08, one cycle. We will just display the bar graph. So you can see here, this is one cycle. FFT analysis was done for one cycle, and you can see it is 5.09. Actually, according to IEEE, it should be coming less than 5. So you can go for some other method also to bring it below 5%. So you can see here the THD graph, and similarly the list of different harmonics, like third harmonics is 0.08. Since it's a three-phase system, it will automatically reduce. So this is a fifth harmonics, 3.26. This actually the data which I have taken is not the correct data. That's why, because fifth harmonic should be 0. According to a problem. So when you solve it, if you get the correct answer, like if you have solved it correctly, if you have taken the objective function correctly and if you have solved it, our main aim was fifth harmonic, 7th and 11th all should be made to 0. So if it comes to 0, your total harmonic distortion also will be less than 5%. Okay, so when you write the program also, you have to be very careful how to do it. So this is about neural network. Okay, so like in here in Simulink, as I already told you, you can just go and choose your area. If you are from drives, you are from power system, you are from power electronics, just you can go to the demos here, go to the help demos. Go into sim power system. So there if you see, you have power electronic models are available already. Okay, so just whichever model you want, say you want be a speed control of DC, with the speed control it comes in drives, you can take any inverter or like something. The single phase PWM inverter is there. Just click on the model. Okay, the model opens, and here you have open this model. Just click on this, open this model, automatically your model will open, and you can just run this model. Okay, and you can get the output here. So here in this model, if you want to apply GA, PSO, neutral Rapson, you can just go see where the firing angle is coming from. See, pulses are generated here. It is coming from this point. Pulse generator is here. So you can remove this pulse generator and you can optimize your angle and you can give it. Okay, so this is for power electronics application. Those who are from power system, I think you can have this utility, and you have all these buses, 5 bus system, 29 bus system with server plant. So just click on that model. So open this model. So in this model, if you see, all your systems are already there. Okay, so some fault is also given. You have a wind generation here. You just double click on this and see. So again, you can have a 9 megawatt wind farm is here, and you have some systems like you have the feeders and all those things given here. So you can just, if you are from this field, those who are from power system, you can go and implement your optimization or this inside this. Okay, so you understood how to make a block and bring into Simulink. Now you have your system here. You can just go and open this, and here these are the load flow. This is 2012 version. If you go to 2015, more like IEEE buses, more buses are given, and you have all the PV systems also. In 2012 and 13, the photovoltaic models are not available. Now the photovoltaic models are also available. Those things also you can integrate it. And this is for load flow analysis. This block, you can just copy it, and if you have your model, you go and keep it. And once you run it, and you can go to the Power GUI. So this is the Power GUI. Okay, this is the Power GUI. So you can just go to the Power GUI and see the load flow analysis data also. Actually, I am not from power system, so I am not much sure about it. But those who are from power system, you can also implement all these fuzzy neural and all inside this. So we'll just see the load, because some participants here have a power system, so it may be useful for you people. It's taking little time. I'll do one thing. I'll stop it and give it for a smaller, because time, I don't know fault at what time they have given. Anyway, 3 minutes we'll run. So here, after going to the Power GUI, you can just see the load flow analysis, all the P values, Q values. And here also you can just think which are the place you can implement the neural network, fuzzy logic, because you have the wind farm and you have PV, all these things connected to the system. So automatically there also optimization may come into picture. So you can just think of it, where we can, like one thing is in power electronics, we mainly see of finding the optimal firing angles for eliminating the harmonics and all those things. So according to your problem, where you have to apply, you have to just think on. So it's almost getting over. So now you can just go and see the displays, the outputs. I've not run it fully also, so might be say some fault might be given here. They would have given some fault here and it is getting rectified. So the thing is, I just wanted to show you the Power GUI and that Power, okay, here, Power GUI is here. If you go to the Power GUI, here you have the load flow. So you get the load flow data from there. So this is your load flow data. Okay, you get all the voltages, base voltage, Vref, and all those things according to what you set. So like those who are from power system, please you can just go and explore it. It is already available. And if you go for 2015, it is still better. You have more examples. You have more IEEE buses. In this, I think they have 29 bus and you have a 5 bus system. And if you go for higher models, you have lot of other buses also, and you can have renewable source of energies. Like here, wind farm where is connected. You can also connect your own models. So till now, like neural network, do you have any doubts? Directly also you can give, like say it depends on your problem. You want to optimize it and give, then you will get better results. Okay. If you don't want to optimize it, then accordingly. Say if you have neural network, say you have hundreds of data, inputs, hundreds of inputs are there, and you want some 5 output. Those hundreds of inputs might be all are not necessary. Okay, so there you can go for principal component method, PCA, or you can have some optimization and you find out which are the parameters which are affecting the output on a higher scale. Those parameters you can choose. For those choosing those, you have some methods also. So PCA, PCA is principal component analysis. In that what you do is, in that you find the eigenvalues and eigenvectors and you find out which are the values which are more dependent on the output. As you know, the eigenvalues and eigenvectors, they never leave their features. In phase recognition, many places they are using it. So even in power system fault analysis and all, they go for these eigenvalue, eigenvector analysis are there, where we say that the eigenvalues and eigenvectors will never leave their direction. Though their magnitude may change, the eigenvalue may change, they will never. So they have the features. So similarly in PCA also, you can find your eigenvalues, eigenvectors, and you can find out which are the parameters which are affecting your output more. You just do that analysis, find out the data, then give it to your neural network. So that will give you a better result. The neural network is, what is neural network? You're training your mind. Okay, so your mind is taking the decision. Depending on different input parameters, our mind is giving us some output. Same way, if your data is good, neural network will also give you a better result. Is it? If you've trained, say if you have not trained the neural network properly, your output will not be good. That is understood. So you should have a very good set of data to train your neural network. Once you train it properly, it will give you the output. Yeah, that should be same. No, I didn't tell about the rows. I'm telling the number of data. Say I had 451 samples. The sample should be same, I said. Inputs can be any number. You can have 5 inputs, 10 outputs. Any number you can have. Inputs and outputs can be any number. Okay, you give 5 inputs and you take 10 outputs, or you give 2 inputs and take 1 output. Any number you can have. What I told you is the number of samples. Say 451 samples I took. Input you took 450 samples and output you take 451. Then it is not possible, because for one input there should be a corresponding output. That is what I meant. It is not that you should have same number of input and output. I didn't tell you that. It is not necessary that all the system will not have same number of input and output. Okay, that is not a problem. Neural network, any other doubt? So I think neural network ma'am has already given you the input, so I don't think, but how to bring into practical things. So even in the next session, I can just show you how to connect it with DSpace or Arduino or some other hardware and bring the output to the real world. So here, if you see, other things you can remove. What I showed you a system, so this multi-level inverter here. When you're real time implementing it, what is required? Your multi-level inverter will be there in real, your motor will be there in real, and your controller is also there. In controller, what will you flash? This neural network. This is required for your final hardware implementation. Okay, all the other things will be in real, and this will be in your hardware. So what will you do? This modulation index you will remove, and you will put a input block where you will be taking the data from the. Okay, so the real time you say here modulation. What is modulation index? Your fundamental voltage and DC voltages. So if you acquire the fundamental voltage and DC voltage, give it to some block which will calculate you the modulation index. That modulation index you give it to your problem, and here you will be removing this. I please show the PPT. So once again, I am just repeating because centers, they didn't see the PPT. Here you see the modulation index is there. So for when you do it in real time, you will not have this multi-level inverter, this motor in software. All those will be the real time there. So there what is required, I will be taking this modulation index. So you can have this calculation of modulation index also. Here we have calculated the modulation index with voltage, like fundamental voltage and the DC voltage. So with that, what you do, you calculate it. You just acquire the real-time voltage, DC voltage also you acquire, you calculate the modulation index and give it inside your DSpace. Okay, so then that DSpace will bring the data into MATLAB, and MATLAB you will have only this neural network window. So this neural network will give you the 5 outputs. This again you will take it out to DSpace and you will control your system. So real time also you can implement it. For that only this is required. You will be just removing these blocks and this block and you will connect the real time. But in real time when you do, one thing you have to remember is scaling of data. Say you have a 230 volts supply or you have 415 volts. You can't give it to your DSpace directly. Is it? So what should be done there? DSpace can take data only from 0 to 24 volts. Not more than that. So in that place what you do, you scale it down. So if it is a AC system, you can have CTs or PTs like current transformers and potential transformers, reduce the voltage to your limit and then you can give it. Or if you have a DC system, you can have some sensors, like you can have even potential dividers. You can have 2 resistors, make voltage drop in one place and take the other voltage and give it to your system. But see that when you give it to the DSpace, your voltage should be within the scale, within 24 volts. So if it is 240 volts, you just take 2.3 inside, multiply by 100, you will automatically get 230 there. So you have to scale it inside your software. Now, like the data which you are getting, you have to scale it inside your software, and your software will run and give you the firing angles. Those firing angles, again take it outside, and those firing angles, when they come outside, magnitude, it is in the form of digital and you are converting into analog, and their magnitude will be less. So what again is required there? Driver ICs. You have to drive them up. So driver ICs are required, and another thing which is required is optocoupling, because this is a digital, like the controller is digital and your circuit is analog. Not only that, the power level is different. This is only 24 volts and that is 440 volts. If you directly connect the power higher potential to lower potential, your current will flow and your controller may burn out. So in such places you require optocouplers or transformers. Isolation transformers are also there. You can have isolation transformers or you can use optocouplers. So when you do optocoupling, automatically this digital circuit and your power circuit, this is the control circuit what we say. The control circuit and your power circuit will be isolated, so there will be no damage to your system. So these things, when you do it in hardware, you have to keep it in mind. Okay, so any other doubt now? Centers, yeah, send. Confusion matrix, I am not much sure. You're asking about the inter this matrix or something? Yeah, एक representation. I've also heard about it, but I have not. Oh, different. Say in neural network, maybe you have different models. Okay, so might be like if you are using a particular model, how the data is coming. वो एक particular method होगा ये confusion matrix through आने वाला एक particular होगा, but I am not much sure. This is a very simple. Those who are learners and those who feel, because we are not actually from computer science or other field getting into it and doing the programming. Since for such people, those who feel it is very difficult, here also say you're getting the coding, so that from coding you can change the methods, you can change the inputs, you can change and you can implement it. That is what you can do. Any doubts from the centers? Okay. So now like next we will go into ANFIS. Okay. ANFIS or fuzzy. I'll first show the fuzzy so that fuzzies or the same way only you'll be doing it in ANFIS also. So next I'll just show you the fuzzy. So fuzzy blocks also already ma'am has told you how to make the FIS also, is it? Fuzzy inference system also she has already told you. So if you have made some fuzzy inference system, you will be saving it in any location. So how to bring it into Simulink? That is the main problem here. So for example, what I've done is I have taken a small example to show you how to bring that fuzzy inference system into MATLAB. So once again, just those who are attending it for the first time, just fuzzy, this is the fuzzy inference system editor. So here you have inputs, you have output, and here the rules are defined. So rules will be defined here. So if you want to add, I would have told you, so you can add input variables. Okay. So how many inputs you want to add, and there you can go and change your membership functions also. You can change your membership function, you can change your shapes and the values, the range also. You can change all these things you have done. So now I'm just going to open one of the model which I have already done. So let us take an example of a PID controller. It is just to show you, because this is just the example which I itself made it. So this is not a proper system as such, but how to bring this fuzzy here, that is what we are going to see. For understanding purpose, we have just made a I think all of you can see this system. So all of you can see the system, I think. Okay, so this is a very simple system. It's a PID controller. You have a transfer function of a plant. Okay, and you're just taking the output. Okay, and the input what you're giving is a step input. The step input we are giving to a system, and the output we are just taking and we are just comparing it, and the error and the change in error we are taking. Here for fuzzy, there are two things. One is the error and another one is the change in error. So these parameters you are fuzzifying, and this is the integrated time. Only the proportional and derivative term we are fuzzifying it. Okay, and this is your integral. So this is a PID controller which is used for this plant for controlling the output. Okay, so here in this system, I'll just show you how to make this fuzzy block. If you run, one second. Actually, there was a small problem. I think the program was changed. Now I'm getting the output. Okay, I'll just show you. Actually, the rule viewer ka window, like sometimes it gets corrupted. MATLAB, like in MATLAB na, when we are doing it gets corrupted. So that's the reason. So I had a backup of the file. Not a problem. I'll just tell you. So this was the window which you saw. Okay, and for a step input, you can see here. Okay, the program is not fully run. So the step input, we are just seeing that it has to follow 1. So here where the PID controller, general PID controller also you can do it, and you can just bring it to bring the output to 1. Here we have used a fuzzy based PID controller. Actually my thing is not to explain this PID controller or anything. The thing is how to bring fuzzy into this PID controller. Okay, so here how did we bring this? How did we make the FIS? How did we bring it into this Simulink window? That is what we are going to see. So I'll be just showing you the steps. So here, whenever you want to bring .fis, like FIS file into Simulink, you have to just go to this library and you have a fuzzy fuzzy logic toolbox is available. Okay, so you can, I think you can see this fuzzy logic toolbox. Here you have fuzzy logic controllers. So here I'm not taking the fuzzy logic controller with rule viewer because there is some problem like my system with the rule viewer. That's why it was giving me an error before also. So I'm taking the fuzzy logic controller without rule viewer. You can try it with rule viewer in your system. This is the thing. So now the FIS which you have created. Do you remember? Yesterday you would have done fuzzy logic and you would have created a fuzzy inference system. How did you do that? Say if you give fuzzy, this will open. You just make your model. So here we have made a model. I am just importing that from file. It was PID FIS which I have made. So this is the model which I have made. Okay, in that you can see there is error and change in error for the PID controller. Okay, so PID nahi hai, there I have integrator. I am not taking only the differential and the proportional term we are taking and we are fuzzifying it. So that for the fuzzy logic input there are two things. One is your error and one is your change in error. These are the two inputs to your fuzzy logic. So error, I have defined the error. I have defined the error as negative error, zero error and positive error. And I have defined the values. Okay, so 0, minus 10 to 10. I have just defined it. It's a triangular membership function we have chosen. These things you can go and change. Similarly, change in error. Change in error also I have kept negative change in error, 0 and positive change in error. Okay, and my outputs are, output is, it may be 0, it may be minus 5, it may be minus 10, 5 or 10. These are my outputs I have chosen. So now rules I have to define. The rules I have defined ki my error is negative and my change in error is negative. My output should be minus 10. My next rule I have defined is error is negative and my change in error is 0, then minus 5. Then next rule, let's say one rule I have chosen ki if my error is 0 and change in error is 0, then my output should be 0. So similarly, according to your thing, you will be having the inputs you have to define. You have to define the membership function. You will be choosing their rules, and after that you will be defining the rules here. So once the error and change in error comes, you just select this and you add a new element and add rule. So automatically the rules are also defined. So this one, what we have to do, we have to, once you have made the FIS, you have to export it to any place you can export. You can either export to workspace or you can export to a file. Okay, so now I'll just export it to workspace. For workspace, let me export it as PID 11. Okay, I am exporting it to workspace as PID 11. Okay, so now you can see here this PID 11 would have come here. This is your PID level in workspace. So the problem in workspace is every time when you say, when now you close the MATLAB, this PID 11 will also go. Okay, so every time it is better you just save it in some folder. So same thing, say STC MATLAB also, I have just PID FIS, I have saved it. In file also you can save, so I have saved it in as PID FIS. So now how to bring this PID FIS into MATLAB? That is the same thing for ANFIS also. ANFIS also will create you a .fis file only. Same procedure only you will be following it for ANFIS. So how to bring this PID FIS into our MATLAB window? So here already we have kept this. Okay. So now what you have to do? Here double click and you can give here PID. I have kept 11. This is it in workspace. So one thing you have to remember is, if the data is in workspace, you can give PID 11 directly. Or if it is in file, two things are there. If your .fis file is in workspace, you can directly give as PID level, apply OK. If it is in file, you have to give within single quotes. Otherwise, your program will not run. Can you get it? So if you have created your FIS in file, give it as within single quotes PID 11 and do it. Another thing which you have to remember is, when you do the problem, all these PID11.fis and your file should be on current folder. So this is my current folder. If you keep PID in your desktop and your program you're running it and your current folder is some other location, your program will not run. Always remember the .fis file which you have created and your file, your main program should be in the current folder. That is a very important thing which you have to remember. Your current folder, your data should be in the current folder. But one thing is, if you keep it in workspace, this problem is not there. Current folder problem is not there if it is in workspace. Okay, you can have it in any location, but workspace, there is no problem. And another thing which we have to see here is, see here there are two inputs to my fuzzy, but here there is only one. How will I change this? Is it? In your library, there is only fuzzy logic with one input. But here I want two inputs, or might be in your system you want 3 inputs, 4 inputs. So that can be changed. Your FIS, how much inputs you create, same inputs will come here also. .fis I created with 2 inputs, is it? Error and change in error. So I can also bring here 2 inputs. So how will I do this? Just go, click and go into look under mask. Sorry, I went into look under mask. Yes, I have to go into look under mask. So this window will open, and here, since the .fis file which I created has 2 inputs, this will also accept 2. But one thing we have to remember is, it will not allow any change here. If I try to delete, it will tell you attempt to modify the link. It will not allow. So what you can do, open one more window. This is very important because you will not get in any book or anything. When you want to modify a window, it is very difficult. MATLAB will not allow you to do any modification. In such a case, what you can do, open one more window, copy this into that. Now this is a new end title, and this you can just close it. This you can modify. Say now you go and just delete it, automatically delete. MATLAB will never allow any change in its main windows. Okay, so for that what you have to do, just open a new window, take that there and you do it. Okay, so now I want 2 inputs. Just click on this. I'm just adding a mux. Okay, I'm just deleting the output also. Okay, and I'll create a subsystem of this. I think all of you know to create a subsystem. You have done till this. Just select it, right click and create subsystem. So now the subsystem is there. So this is nothing but your fuzzy system, this one. But I want this picture on this, or you want to have your own picture in this. So for that what will I do? I'll just go to this edit mask. This is the edit mask window where the icon drawing, say you can have the plot command here. Same plot command, go to this window and create mask, copy it here, apply, and you will see that fuzzy logic block came in this also. So now you have made your own fuzzy logic block with 2 inputs. Okay, so if your .fis has 5 inputs, you can again go and have a mux and you can change it, but it will not allow you to change in the main window. You can do it here, but still this is not over. See, when you click on this, this window opens. Similarly, when you click on this, that should open, because here you have to give that PID.fis also, no? So that you have to again go and create it. So you just see what is the format here. Same way we will create. And here, say here I have kept a fuzzy logic block. If you want to have your own image also, you can have it. If you want to have a, say, image command is this, im image im read, within quotes if you give this, apply, so that image will come. So if you have made a solar panel, you want a solar panel there, you just go to the Simulink location. It is here. Go to computers, C drive, program file. In program file only always we keep the MATLAB, no? So go to that location, MATLAB, MATLAB 12. There I have my toolbox. In toolbox there will be Simulink. In Simulink again one more Simulink. So that B7, this is that aeroplane picture, B747. Same location you put your image, whichever image you want. See that the resolution should not be very high. Normal resolution. It is not like very high pixel picture. If you put, sometimes question mark will come there. And the other thing is, once you put the image also, sometimes it will not come. You have to shut down your system and then restart it. Then only it will come. Okay. So here we have one more image also. I can just show you. That was Simulink team, I think. So this is a Simulink team image. Already it's saved in the same location. So any image you can have, because many people they will do with wind. Some people they work with some other system. So when you want that here, you can just give this link. Okay. So how will you go? You go to this C drive where the program file is there. Go to your MATLAB. First you will go to toolbox. Then you will go to Simulink. Again you will go to Simulink. So you will get this play location. That location you have to put it. Now this is not over, is it? We want that other edit window. So just go to the real window, and what is there? You have this parameters. So two things you have to define. One is your FIS matrix and another one is TS. Okay, so that is there in this matrix, but here I don't want this TS, I think. TS also I have defined. Okay, I have defined that TS also. So here also, edit mask, I'll go to parameters. Okay, I'll add two. One is my FIS matrix and another one was my sampling time. You can give any variable here, but the variable which you give here should be matching. So this is FIS. What was FIS matrix only, I think. FIS matrix, and this was my TS. Once again, I'll just check. FIS matrix and TS. So same thing I have to give here also. Okay, I didn't save it. I forgot to save that. Here you can give anything, it's not a problem. Here that should be same, FIS matrix, and this should be your TS. And apply. Then if you want to initialize, you can give your initialization and some documentation also you can give here. Then apply. Okay. So now if you click, that window will open, and here you can go and give what values, like that PID which we have saved. That PID will be given here. This PID within quotes I have given because I have taken from the file. I have given this PID within quotes because I have taken from the file, or I can run that PID 11. Okay. So this is how we create this fuzzy logic block. So this I itself created it because in fuzzy logic toolbox there is only one input. So here for my problem I just wanted to show you a two input problem. So that's why we have created it. So here you can see here, PID. So I just already showed you, it was running, I think. So this output was coming. So similarly, we had created one more. Is it within single quotes? In workspace we kept, so that 11, I think it was PID 11 in workspace. So that also you can apply. If it is in workspace, then no problem. Your current folder also can be different. But if you keep it in the file, your current folder should also be the same location. So you can get the output. Okay. So similarly, your application also you can fuzzify or do anything, create your .fis and you can bring it into Simulink. Okay. So now we'll go for a short tea break. You can have your tea, and again we'll assemble back after 10 minutes. I think now it is around कितना हो गया यहाँ उसके time पे 11 वहाँ उसका चाहिए 11:33 है ना. So 11:45 we will reassemble. Okay, at 11:45 we will reassemble, and once again I am announcing the for the nodal centers the validation will be at 1 o'clock. So sharp 1 o'clock, around 12:45 please all of you get assembled. So we are a little late. We are very sorry because there was some problem here with our tea came late. So that was the reason. So anyway, we are just starting with the next ANFUS. Okay, so ANFUS is Adaptive Neuro-Fuzzy Inference System. That is also inference. So you can just get from the name itself, you can get that the final product will be a .FIS in ANFUS also. So for that FIS, you can directly implement in Simulink, similar fashion of fuzzy. How did we implement fuzzy? Same way we will be implementing ANFUS also. So ANFUS, the toolbox is no, I would मैं फिर ले लेती हूँ कुछ problem. Okay, so now ANFUS edit. So the command is I think so the command you can see here, the command is ANFUS edit, or I can just expand because there I think the centers will not be able to see that. So this is the command ANFUS edit, ANFIS EDIT. If you give this command ANFUS edit, so the command is ANFUS edit. If you give, this window will open. If you give the command ANFUS edit, this window will open. You can see here ANFUS edit window. Okay. So now we will be working on this window and form the model. So before going into this, what we will see a simple, like with a single PPT, I just want to show what is this ANFUS.
Ma'am, volume is very slow.
What is slow?
It's not audible. Volume is very slow.
क्या नीचे करना है? Okay, in this mic it is going. It is not through this laptop. I think now, is it audible now? Is it audible?
It's audible. Now it's okay.
Okay. So now only I'm going to start. We will be seeing what is ANFUS and how to implement it, and then how to take it into Simulink. Okay. So you can see here a window. So this ANFUS, as a name suggests, it is Adaptive Neuro-Fuzzy Inference System. The structure is similar to that of the structure you can see here. This structure is similar to that of neural network. Okay, so here you can see the neural network structure, similar structure you have here. Okay, but the input which you give is fussified. Okay, so here you have two inputs, x1 and x2. These two inputs, first what we do, in case of neural network, say if we have two inputs, say temperature and moisture, what we do, we give it directly. Temperature and moisture will be the input to the neural network, and you have some control output, or like if you have the duty cycle as the output of the neural network, you will get that. But in this case, the temperature also, what we do, we fussify, we just give two inputs. Here we have defined two linguistic variables. Say if x is the input, x is the temperature, you have two linguistic variable, a1 and a2, which you can see here. A1 and A2 are the two linguistic variable, which means that low temperature and high temperature. And that again you give the membership function. Like you define the membership shape for it. It may be a triangular membership function, it may be a trapezoidal. That you have to see according to your problem, you have to see how it is varying and you have to choose it. So for X, and similarly one more output, Y. For that you have defined two membership functions. Two linguistic variables you have chosen. For Y also B1 and B2. say Y is moisture, low moisture and high moisture, it's something like that. So you have chosen two linguistic variables and its membership function. Now after that, the weights W1 and W2 has to be defined. So this defining the weights, it depends on this weight W1 depends on, say if X1 is a particular value, X is, let us take the temperature is some 67 degrees C or something. So for that 67 degrees C, you will be seeing what is A1, and similarly for say like you have a moisture particular value, for that B1. So A1 and B1 will define your weight W1. Similarly, for the same value, A2 and B2 will give you the weight W2. Okay, so after that, after getting W1 and W2, you go to this is one layer, and the next layer will give you the like strength with which you are going to fire. W1 and W2 will automatically give you the strength, but still that W1 you're multiplying with some function, so that will define at what strength you're going to fire the system. So here Z1 is nothing but Z1 is some constant P1 into this X plus Q, this X, that is input, Q1 into Y plus R1, and similarly your Z2 is nothing but P2 into X plus Q2 into Y plus R2. So some function, you're just multiplying with the some function, and again after that say W1 X1 is coming here, W2 X2, and similarly W1 and W2 are directly going to the summation point. So here Wi into Zi and sigma into Wi. So that Z, the output is nothing but weight into Z1 plus weight into Z2 divided by W1 plus W2. This is how overall output you get. So the thing is, structure is similar to a neural network. The input what you give is fussified and it is given. So this is one of the model. For ANFUS, adaptive neurophysics, you have number of models. If you want to get more detail about this, you can take this paper. Like this is the base paper of ANFUS. Yeah. Okay. हर्षुत एक मिनट. ओके, ये वाला ना ये क्लोज करना है मुझे लग रहा है मैम. ऑल टैब से, ऑल टैब से, हाँ ऑल टैब से कहाँ है मैम?
कोई और विंडो अपने?
नहीं, ये जो विंडो है ना, 1 सेकंड मैं शो यू. वेयर इज इट? दिस वन. ये क्लोज करो. यहाँ कैसे क्लोज करें
मैम? ये क्लोज नहीं,
मुझे इसको क्लोज करना है. ये कैसे किया था?
हम इसकी ना यहाँ से
ओके.
इसको वो उसको भी मैम ऐसे ही कर लेंगे.
Okay, this one I close. Actually, that paper is here. So this is the base paper of ANFUS. So those who want to do research with ANFUS, you can just go to this paper. Okay, I think in the centers whether the full screen is coming. The full screen is not देख लो.
सर जस्ट प्रेस F11.
हाँ अभी आ रहे हैं मुझे लगा, फिर भी फुल स्क्रीन नहीं आ रहे. क्यों? नहीं वहाँ नहीं आ रहा. नहीं, आप एनीवे पूरा स्क्रीन बाकी दिखाते समय भी पूरा स्क्रीन आएगा ना. इसका कुछ रेजोल्यूशन डिफरेंट है मुझे लग रहा है, उसका नहीं है. कैन यू अंडरस्टैंड? ये हाफ स्क्रीन ही ट्रांसमिट हो रहा है.
बाकी पेज तो फुल आ रहे हैं.
नहीं वो नहीं आ रहे, सब कट रहे. अभी तक तो नहीं था, मुझे लग रहा है कि ये लेते समय वो तो क्लोज कर देना.
मैंने इसका ना आप वो कर दो, डबल क्लिक.
नहीं अभी तक ठीक चल रहा था, मैं तो देख के कर रहे थे ना. ये भी नहीं है, मुझे लग रहा है कि हमने वो मल्टीपल विंडोज लिया ना तभी कुछ हो गया.
आई नहीं रही है मल्टीपल विंडोज. इसका ये मल्टीपल विंडो वाला ऑप्शन ही नहीं आ रहा ना। हाँ वो नहीं आ रहा। हाँ नहीं आ रहा ना, प्रेसिंग हो रहा।
अभी कीबोर्ड चेंज किया था न्यू कीबोर्ड। अभी थोड़ी देर के पहले मल्टीपल विंडो आ गया था ना। रेजोल्यूशन
वो वैसे सेम ही था, उसको चेंज नहीं किया था हमने।
किसको?
रेजोल्यूशन 100 ही था ना।
नहीं मैम ने चेंज किया था। वो प्रॉब्लम नहीं है, वहाँ देखो हाफ ऑफ द विंडो ही आ रहा है।
कीप चेंजेस।
आपकी वहाँ की सेटिंग तो नहीं है?
नहीं मैम, ये यही जा रही है ना डायरेक्ट।
जी किया है ना हमने, तो डुप्लीकेट ही करना है। फिर मैं एक काम करती है, हाफ विंडो में मैं वहाँ देख के करूँगी कि
एक बार इसकी ना स्क्रीन शेयर दोबारा करना, कैंसिल करके। स्क्रीन शेयर दोबारा।
फिट टू स्क्रीन नहीं, मुझे लग रहा है कि इसका
हैंगआउट से स्क्रीन शेयर, क्योंकि इसमें तो सही आ रहा है।
अभी आ रहा है मुझे।
अभी
फुल आ रहा है। ओके। So I'm just showing you the ANFIS paper. So this is the adaptive neurofuzzy inference system paper. Jack Singh, Roger Jang का है. So this is an IEEE transaction paper. You can just go through it. Different models of adaptive. What are the different models available? And here they have clearly explained all the functions and the internal things. So मैंने भी इससे ही वो लिया है जो explanation. Here you can see A1, A2 and B2, the functions, how it's defined. So they have different clear correspond, like you have so this was the thing. So you have the ANFIS architecture. So here two inputs, X and Y are your inputs, and the rule base is defined like that. If X is A1 and Y is B1, then your function F1 is Px plus Qy plus R1. Similarly, your next is say A2. If X is A2 and Y is B2, then your F2 function will be this. So these are the two rules which are defined. Okay, so this paper fuzzy inside, like there we saw na, you had A1 and like say X and Y as two inputs. X had A1 and B2, then the weight was defined. After that, the rules according to which rule will be fired. So here only two rules are taken. You can have multiple rules. If here in this case it is given X is A1 and Y is B1, your rule is function F is equal to P1X plus Q1Y plus R1. So that is what we said, that W is multiplied with this function, and that will give you the strength at which that rule is fired. Okay, so there we saw that. So you can just go through this paper there where very clearly they have given the different layers and they have explained it. Okay, so this paper you can go through. Once again, I'll just show you the heading. You can go through this paper. This is adaptive neurofuzzy inference system, IEEE transaction paper. It is Man in Cybernetics, volume 23, number 3, May, June 1993. Okay, so this paper you can just, it is Jan Sang and Rover Jang. Okay, so this paper you can go through. Now I am just going to the toolbox, because toolbox is just like, you will not understand what is going inside. So just I told you what is going inside. The toolbox is very simple. What you have to do is you have to just give ANFIS edit and just click on it. The ANFIS edit window will open. Okay, now you have to load the data. So similarly, the last example I showed you, here also you can have multiple inputs and one output. Mostly in this case, ANFIS, the toolbox is made in such a way that you can give multiple inputs and one output. So all these inputs and output, you will have it in the same file. Last case, in neural network, you will be having input separately and output separately. In this case, it is not like that. Here you can have same file, and you can have a notepad or even Excel file. So here we have a notepad. So now I have to load the data. So I can just show you the data before loading it. So this is the notepad data which I have stored. The same data only which I showed you in the morning, same data I have taken. So here in this case I have just changed. I am having 5 input and last one is my output. Okay, so in this case, ANFIS, this tool, you can give any number of input but only one output you get. But in my case, it was, I showed you, I had only one input and I had 5 output. And this tool, I changed it in such a way that I got multiple output also. So that is in your hands. Once you get the Simulink model, you can go and work into it and you can change the model also. Is it? So you need not worry, you can have any number of output also. But now I'll show you for one input, like multiple input and one output. You can give multiple outputs also, that I'll tell you how to do it at the end. Okay, so here you can see I am giving 5 inputs. So I have kept it in the column form. First input, second, third, fourth. So 5 firing angle are my input and last modulation index I have taken as my output. So this data I have to just load into my ANFIS. So this is my ANFIS window. So load data. It is asking me for the data. So I am just going to. So this here, it is here, ANFIS, I have kept it in the notepad. Okay, so you can just see I have just stored the data in ANFIS. So I have just taken it and open. So it is opened, the data is opened here. So this data has both input and output. So whichever input or output, you have it in the column form in this form. And next, if you want to load it from workspace, you can load it. So now I have loaded from file. And next is generate FIS. So now generate FIS, in the sense I have 5 inputs. So for these 5 inputs, the .fis file has to be generated. Similar what we do it in fuzzy logic. So now you can have this also grid partition or subclustering. These are the different methods by which you can do it. You can try the subclustering also, or grid partition. You can just select and generate FIS. So when you give generate FIS, this window will open. Okay, so here you can see now how many inputs I gave? 5 inputs. So 1, 2, 3, 4, 5 inputs are there. You can define the membership function, like what type you want, triangular membership, trapezoidal, G-belt, whichever you want. And here you can just go and change the number of membership function also. Say for first one is, let me take it as temperature. So if temperature low, medium and high. If you want 5, very low, low, medium, very little high or very high. So how much ever you want to take, all those things you can define here. You can go and change this also. Okay. Next, whether your output is a constant output or it's a linear output. Okay, so here you can just choose that also and click OK. So now the FIS, we have defined the FIS. Next we have to see which optimization method we want. Back propagation want or hybrid. Hybrid is least square and back propagation the combination hai, or you have back propagation. So whichever method you want, that also you can choose. Error tolerance, like what is it, mostly 0, or if you can even, if you can have an error 0.05 is tolerable, that value you can give. Then epoch, number of iterations you want. So if you give like you have a big data and you give 20, 30, it will take the whole day. Okay, so I have given the minimum epoch, like minimum iterations 3, and now I am going to train the data. Okay, so I am just giving train. Column, last column is output. So now it is training, and you can see here some error is there, and here the error is 0.7294 is the error. Small error is there in this case. And here structure, this is the structure. You have 5 inputs. Okay, and membership function, 3 membership functions I have defined, and this is my output. Okay, so this is the overall structure. And I have one output. And here the logic you can see, and logic is used here, rules may. Okay, or not, those things also you can define it. And now if you want to go and see the FIS properties, this you can see. जो fuzzy में हमने देखा है, same way here input is this, say here 3 membership functions, all these membership functions are there. If you want you can change the name, if you want you can change the shape, if you want to change the parameters वो भी आप change कर सकते हैं आपके accordingly. ये क्या है कि what data you have given, according to it optimized value it has given. If you feel I don't want this membership function, I want to change it, you can just change it in this end. You can see. Similarly, the 5 outputs ka or sorry 5 inputs or output ka data you can see it here. Next is you can have, if you want to add variable rules, you can see the rules which are created here. These are the different rules created in your output. You can change it and also see what is how it is varying. Okay, accordingly the output also will change. So now I'm closing this, and you can see the rules here around 200 and something, I think 243 rules are all automatically created depending on the number of membership functions which I have given. Okay, so rules are also there and output. Then and you can see the surface plot. So this is the surface plot you are getting for your option, your thing also you can see the surface plot. And now I'm just going to the ANFIS window. So this is what we get. So here, whichever ANFIS like fuzzy parameters, you can go and change there and you can do it here. Okay, in the main window, you can come and see what is the result. So now we have trained it. Now we have to test the data now. So for testing, if you want even testing data, you can take one more testing data. You can load the testing data. Okay, I don't have testing data, but if you want, you can load the testing data. And with testing data, you can test it. Once again, you have say whenever you have some 400 data, you keep 300 for training and baki 100 you can keep it for testing. Again, you can load it. But one thing you have to remember is when you're loading the training data, at the same time you have to load the testing data also. At now this point you can't go and load the thing. It will not allow you. So when you have checking data or testing data, the starting itself when you load, you do the training data and testing data also you load it at the same instant. So now I have with the same training data which I have taken, say around 500 or something data which I have taken, same data I am testing it also. So here it is almost different. It is coming almost, it should come on the same line. My data is not so proper, that's why it is coming in a different line. Otherwise this red line should go over this blue line. Okay, I think the data is not so proper. Once again, I'll just try with some other data. I have taken a wrong data. This is the data, but so now it's coming over, because if your data is proper, then what happens? The training data and the like your test data both will come on the same line. If it is coming in different line, you have a very big error. Okay, then what you can do, you go and I think when I changed the membership function or something had happened, that's why it was not fitting. Okay, so from here itself you will understand you have a very big error. Then again what you can do, you can go and change the membership function and all, see, and you can fit it. So now this is over. Till test now it is over. Now what we have to do, we have to import this to the file, just like a .fis will be created. So now I am just importing it to file, or some workspace also I can do. Sorry, no, I'm not importing. I'm very sorry. I have to export it. I'm very sorry. We are exporting it to file or workspace. The model which I have made, I have to export. So I'm exporting it to workspace. Let me give the name ANFIS 12. I am giving the name ANFIS 12. Okay. So automatically this ANFIS 12 will come here. See here the ANFIS 12 structure is created. Okay, so this again, how will I take it? Say here you can see in the workspace the ANFIS 12 is created. Now again I'll open. I'll open a model window, and this model window same fuzzy block, because this is also creating an FIS, so you can just go for the same fuzzy block. So I have taken the fuzzy block, and fuzzy, how many inputs are here? Here around 5 inputs and 1 output. So 5 inputs, so I'm taking a mux to give my 5 inputs. Okay, I'm giving 5 inputs. Here these 5 inputs may be from some real-time system. If you have a motor or you have some system, from there these 5 inputs should come. Here simply for an example, I just want to show you an example. That's why I've just written here, and I am just connecting some constants. Okay, I'm just taking 5 inputs as such. Now output, let me see in a display. So the data, so I've already trained with this data. So same data, let me take one value and just give it. So if it is giving the correct, we'll see whether it is giving correct answer or not. And in case, say now you have trained it, now if you give a new value, it will predict what will be your output. And if your data is so strong, it will give you a correct answer. Okay, so this will give you the thing. So I'm just taking this values. If you give it in a real-time system, it will work continuously. Last model I showed you, the same way you can give this in a real-time system also. I think I went in a wrong block. Like, it's okay. Anyway, I'm giving some values. We will see what output we are going to get. So here, now we have to give the structure same way. For similar, like fuzzy, what you gave, same way you have to give here. So here, if I'm taking from workspace, I told you from workspace, you can just give directly. So it is ANFIS 12. Is it? That is a name which is here, ANFIS 12. So same name I will give here also. So this should run. So it is giving me 0.5086. Okay. So actually what happened is I was giving in a second row and the row was changed. Otherwise it will give you the perfect answer. The row which you have taken. And in case, that is the thing. In case if it is a different value also, it will predict what will be your output. So in a real-time system when you're giving it, it will give you the correct answer. So this is how you will be implementing it in a real-time system. So the advantage of this tool is any data you have to just give, and it will form the model for you. It will just create the model for you. You can just give the inputs here, it will give you the output. Okay, is it clear? So this is a very simple model. You have to know the system properly, and you have the data, you can just train it. That is what you have to do. Linear, if it is linear or if it is varying, you can accordingly give it. Okay, here I have given key for these values, I have a constant. It is not going to vary. For these inputs, this is my output. In case that output also may vary, then you can accordingly choose it. Okay. And here I told you, say this is 5 input and 1 output. You can have multiple outputs also, because in my case it was multiple output. So what I did, so each input, you train the output, you get all the models joined together, and you make a subsystem. There, if you now give one input, you can get multiple output also. So I tried that, and I am getting the correct answer. But the thing is, model will become little big. But what you can do is, you can put everything inside a subsystem, and you can make. So multiple outputs also you can get. But one of the disadvantage of this tool is only any number of input you can give, the last one will be taken as the output. Only one output. But what I say is, with this same tool, you can even get multiple output. For that, what you do, you make FIS. Like say, with 3 inputs you have and 1 out, like 2 outputs. The 3 inputs with this 1 output, you train it, you make one FIS. With the same 3 inputs, you make the another output, you train it. Now 2 FIS you get, bring the 2 FIS here and connect them in parallel. And now you give 3 inputs and make the 2 outputs, you put a demux and bring it out. 2 outputs you get, and you get the same answer. I have tried with my system, you can get it. So multiple outputs is also possible with this system. Okay. So next is, say some people may have ki, I don't want to do these tools, I want coding. I want to embed my coding there. So for that also you have options here. You can go to this. So user defined function, you have something called MATLAB function. Okay. So with this MATLAB function also you can write your coding there. If you have a GA problem or you have a PSO problem, you have a real-time system fully there. You just think you have a full plant here, and your plant input, what you're giving it to your system is U. I'm just taking this constant and I'm giving it to my this system. And you can go and write the program here. आपका GA और PSO का आपने coding किया है, और neural network का भी कुछ लोग coding करते हैं. You can put your full coding here itself. So what will happen? Say you have given, in case I have 2 inputs, U1 and U2 are my 2 inputs, and I have 1 output, or say I have 2 outputs also. I have Y1 and Y2 are my 2 outputs. And I have some function like, say my Y1 output is equal to U1 into 100, and my Y2 is equal to some U2 into 20. Simply I have written just to show you that you have a GA or some program here. GA is having 2 inputs, so you have given that input through this, and your GA का जो output है यहाँ से ले सकते हैं. Similarly, the morning का जो मैंने problem दिया था, modulation index you can give it here, and my angles θ1, θ2 will be 5 angles here. Okay, so when I write the whole program when I write and I close it, automatically this system will also give you 2 inputs and 2 outputs. So those who want to write coding, they can embed this here. So I can just show you the output sync भी use करके आप output display कर सकते हैं, और scope में भी देख सकते हैं. You can just see it in the scope also. So that is also possible here. Actually, there is some problem with my MATLAB. That's the thing. उसमें कुछ corrupt हो गया उसकी window. But this will work. वो fuzzy का कुछ corruption है. That's the problem. Once again, I'll just try it. Yeah, some problem is there, Abhi. Otherwise, it will give you the answer. It is actually another thing is this MATLAB. This function should work. आपका जो C compiler proper होना चाहिए. In case आपका C compiler आपके system में corrupt हो गया, then it will not work. So that is a problem. Otherwise, this will work. Okay, so this is also an option where you can directly write your program. You can directly write your program here, and you can run the system. जो भी आपका जो MATLAB और Simulink, sorry, neural network, fuzzy, PSOG का program है, that also you can write it in this portion, and if you run it, it will give you the answer here. So that can also the यहाँ का जो output है, that you can directly connect it to your real-time system. So that is also possible. And here आपको ANFIS coding भी चाहिए तो coding भी है. Through coding also you can do. You can just go to the help and just search for it. So here there is a simple example they have given where you can do the coding in. So in this, if you see, I think it is visible. So X value they have defined the Y value, the training data, the X and Y training data they have given, the number of membership functions, the membership function type G, bell or what, the epochs, how many epoch you want, then to generate FIS. So what the toolbox what we did, same way coding is also there. Gen FIS. So FIS के लिए क्या क्या parameters देना है? You have to give the training data input, the number of membership function, and your membership type. That is what you have to give. And you're just calling the function ANFIS. ANFIS training data and this FIS and number of epochs. Okay, and then you are just here plot करने के लिए दिया है. So like this also you can run the program. So आपको training data and ANFIS output data है. So those who are not willing to do the toolboxes, you can write your own coding. Coding का जो just command है ANFIS. Similarly neural network में भी आप जाके यहाँ neural network का search कर सकते हैं. They have given small problems they have given. So go to the help and learn from there. What are the steps? What they have given? How to do it? So coding चाहिए आपको coding में भी जा सकते हैं. Toolbox चाहिए toolbox में भी जा सकते हैं. And the best teacher for MATLAB is the help of MATLAB. Please go to the demos. कुछ भी आपको चाहिए वहां से आपको मिल जाएगा. कोई भी बुक्स भी जाने का जरूरत ही नहीं है. All people those who write books also like might be their PhD work or something they can give more in depth, but otherwise all the help, all basics things you will get from MATLAB help itself. Each and every tool they have given how to work, small examples and everything is given. So what you have to do is you have to just go to help, go to demos, and whichever tool you want you just search, you will get the demo, and after that you can go and work with that. Okay. So now I'll just show one more thing, how to implement it in hardware. So with DSpace, even Adreno, all these things you can just directly implement. The same concept only, MATLAB Simulink with DSpace interface. So here MATLAB, for a simple example, I have taken a PV system, okay, and we want to track the maximum power point. In this case, I want to track the maximum power point. So in that, you can see here, we have the PV system. There is a current sensor, a voltage sensor. So acquiring the current and voltage, I am giving it to the DSpace. From DSpace, this is just a DAC card, data acquisition hai. It will take the data to the MATLAB Simulink environment where I have written the MATLAB coding. Okay, from there it will generate me the duty cycle. So my inputs are voltage and current, and my output is duty cycle. Okay, so what is actually done? I have to track the maximum power point. So maximum power point, when it will be transferred from load to source to load, when the source impedance is equal to load impedance. So that impedance matching is done by this buck converter. Any DC to DC converter you can keep here. So by perturbing it or by changing the value there, by changing the duty cycle, MOSFET, when MOSFET is fired, automatically it will perturb the system and it will match the impedance here. So at that point you can reach the maximum power point. For example, say this point, you have to reach this point. आपका maximum power point ये है. So इस point को reach करने के लिए you have different methods. One of the method which I told you was perturb and absorb. That is the thing. Voltage and current को ले लो, or you write the algorithm and you find out the duty cycle at which you have to fire so that impedance matching occurs. So for example, in this case है आपको इस point में आपको एक voltage and current मिला. So ये maximum point है. वो कैसे पता चलेगा? इस सिस्टम को अगेन परटर्ब करके हम देखेंगे कि वोल्टेज इंक्रीज हो रहे हैं और डिक्रीज हो रहे हैं. सो अभी नया वोल्टेज V1 and I1 we have got. I have got a new voltage and I can see that this is increasing. If it is increasing, I mean that I have not reached my final point. I can go still. So again I'll be like perturbing the system. I'll be disturbing the system. Okay. And once it reaches the point, then what happens? The voltage and current is decreasing. So then I understood that I have crossed the point. Go back to this initial point. So that is perturb and absorb. Or you can have some other methods like say incremental conductance. In that what you do, you find, you just draw the slope of the system. इस system का slope draw करेंगे. If it is a positive slope, it means that it is like we are on the right side of the MPPT. If it is a negative slope, we find it is we have crossed the MPPT. And if it is zero scope, we have reached the MPPT. So there are different methods to track the MPPT. So ये सबके लिए क्या चाहिए? Voltage and current will be your input and your output is duty cycle. This is a simple example. Okay, so for that system, what we have done here, we have done the algorithm. Perturb and absorb का जो भी algorithm है, उसको इसके अंदर लिख दिया. यही मैंने embedded block दिखाया था आप लोगों को. So you can go and write the block. So here there I am giving 4 inputs. 2 input is through MATLAB itself, and here 2 inputs I am giving through the outside world through Arduino. Sorry, not Arduino. Here DSpace I have used. So ये DSpace का block है, analog to digital converters. 2 blocks हैं. उसमें से मैं अंदर data दे रही हूँ इसमें. So what will this program will run and it will give me my duty cycle. With that duty cycle again I'll take it outside and I'll give it to the DSpace. Can you get it? So here same way, say if this is your buck converter, if you can take it as a buck converter, then you have the PV here and your load here. Okay, so here हमने इसको connect कर लिया and this इसको load में connect कर लिया. So what I can have here a current voltage sensor. So I am having a voltage sensor and here I am having a current sensor. So this voltage sensor ka data, I am taking it, that current sensor ka data and similarly voltage sensor data, and I am giving it to my DSpace here. I'll be giving it to the DSpace, and DSpace, so DSpace will give me an output which is duty cycle, and this DSpace is connected to a computer. So here you just think this is my laptop where I have written my program. Okay, and this DSpace will give me my output and it will be firing my DC to DC converter. This is my DC to DC converter. Okay, and this is my load and this is my PV. Okay, so this is the overall system. So what I'll do, ये मेरा hardware है, real time PV है. This buck converter is also my real time and this load is my real time. This is the DSpace. ये मेरा DSpace है. This is my DSpace. So what happened? When I did the problem, MATLAB में what I did, I simulated the PV, the buck converter, load, and this program was written, it was run. Once it is run, I am sure that my system is working. Okay, simply I had a test. Now it is working. Now what I can do, I removed, like यहाँ जो PV है मेरा सिमुलिंग में, उसको remove कर दिया. मैंने load, buck converter, everything remove करके only my algorithm I am taking. This algorithm may be your GA algorithm, this may be your PSO algorithm, this may be a neural network, any system. This I am taking, and now what I am doing, I am just real time. So this is my D space. This is my real time system. There I have had a, say, Hall effect sensor, current sensor, and a Hall effect voltage sensor. I am taking the real time data and I am giving it to this point. Okay, and now from there it comes into the MATLAB environment. This is inside the MATLAB environment. Actually, I am defining a port here. Analog to digital port 5. Channel 5 के अंदर लेके जा रही हूँ मैं इसको, और इसको मैं लेके जा रही हूँ first mux में 1 के अंदर लेके जा रही हूँ. That will come into my MATLAB environment. My MATLAB is here. Okay. So after coming into my MATLAB, it comes into my program. It will run my program. It will give me my duty cycle. This duty cycle will again go to my D space, and from D space it gets fired. It will fire my buck converter. Okay, so this is how we do the real-time implementation. Once you have developed the program, you can do the real-time implementation. So this is with neural network. The same system with neural network you can try. Same way MPPT with, I have just trained my neurons. Like real-time also, say with some other method, I have found my voltage, current and duty cycle. I can just implement it using neural network, or any method you can do that. So this was a real-time implementation which we have done in the lab. So where we have, so here you can see, this is a PV, this is a buck converter. So this is a buck converter, and this is the MATLAB environment. This is a MATLAB, and here these are our sensors. A voltage and current sensor we have here. The circuit which I showed you initially also, now I drew and show same thing here. And this block box which you can see here is our D space. This is my D space. Okay, so what I'm doing, I am having the PV, and this is just a panel. This is just voltmeters and ammeters. There is nothing to nothing to worry about this system. This is just the indicators, like just voltmeters, ammeters, and they have given the load also. This system, and we have purchased from EcoSense. So here a DC and AC load is also there if you want to use it. So here this is the PV. PV ka input we have just we have just acquired it, and this PV input is around 17 volts. The output voltage of this PV is around 17 volts. So morning also I told you this 17 volts you can't directly give it to your D space. Okay, around 24 volts, like say D space around 10 volts, 0 to 10 volts it is acceptable. Even you can go till 20, but it is not, like say now you have given the 17 volts directly, and in case some short or something occurs, your system will get burned off. So what we did is this 17 volts we reduced to 1.7. Okay, for that we used a potential divider. We used 2 resistors in series, and we divided the voltage. Around 10 volts was dropped, and 1.7 volts we took it, like around for like 17 in the sense 16 volts तक हमने drop कर दिया, and only 1.7 volts एक resistor के across drop करके, that 1.7 we took inside, we multiplied by 10 and we got the 17 volts inside our software. So that should be kept in mind. You cannot take the voltage as such inside. So there we have used current and voltage sensors in order to take the data inside. The data has gone to D space, so you can see the wires here. This is the D space and the wires which you can see here. So these wires, these are taking the voltage, like here we have given 4 inputs. One is the voltage, current, temperature and irradiation. So 4 things we have taken, and जो irradiation, so irradiation measure करने के लिए हमने एक irradiation sensor भी बना दिया, because we had that irradiation meter, but उससे voltage तो अंदर नहीं दे सकते. So we made an equivalent irradiation sensor also. वहाँ से हमने data इसके अंदर लेके गया. Okay, so this was done. Irradiation and temperature LM35 was used, and all these 4 datas were taken inside, and we just did the programming. So I think now we are almost to the end. This is the D space. The D space parameters are also given here. I think you can go through these processors. Okay, the processor detail you can just go through net, and this is the Simulink. Once you install DSpace in MATLAB, this will be the Simulink block where you have this master PCC. Uske andar aap click kiya to you will have the analog to digital converter. So this one only I have dragged and I showed you that perturb and absorb system we had here now. This block. Once you install DSpace, you will get these blocks. This block, and this block. It is there inside these things. So just drag this and put it inside your Simulink window. And these are the outputs what we have obtained. And this was the overall algorithm. We had conducted perturb and absorb the incremental conductance, like perturb and absorb, incremental conductance, neural network, adaptive neurofuzzy, all these things we carried out. And the different results, like around adaptive neurofuzzy, we got a very good efficiency, around 87.15 to 93, because this is a system we are running the system in different conditions. We around 6 months we were continuously running. In summers, winters, we took different readings, and the efficiency, it was not constant, it was varying. So the average, it was 87.15 to 93.31 was the average values we got with adaptive neurofuzzy. This was neural network का data ऐसे आया था, incremental and fuzzy. So these are the different things. If you have any doubts, you can just ask me. This is the procedure for doing. I think we are going out of time, but for DSpace करने के लिए you have some procedure also. So you can just other videos are also available on this DSpace, especially for hardware interface. So you can go through those videos. How to interface this DSpace with MATLAB and all those things are there in this video. Now, if you have any doubts, you can ask. If you have any doubts, you can just center. Vijayawada.
Yes.
No queries, ma'am.
Okay. Next center. DIT.
No doubts from this side, ma'am.
Okay.
We will have to.
Dehradun is also over. Next. Government Engineering College, Gurgaon. Government College, Gurgaon.
No, ma'am. No, it's clear.
Okay, ma'am. Next center. Yeah.
Madam, good morning.
Yes, good morning.
This is Gate College.
Yes, sir. Yes, ma'am.
Madam, is unfish window
Yes, ma'am.
useful for other learning machines as well?
Useful for?
Other learning machines. Just like the way you explained the one learning machine using the unfish window.
Yeah.
So can you implement other learning machines? For example, export learning machine in this window.
No, I can't understand your question.
Madam, can you implement other learning machines?
Machine learning techniques you are asking, is it? You're asking for machine learning techniques.
Implementation, ma'am.
ANFIS is also a machine learning technique. Okay. Neural network is also a technique. You can use this for other applications also. It is not only here. For any applications you can use. Okay. This is just like neural network. Only thing is the inputs, the weights you are fussifying it. Okay. It gives you a better result compared to neural network. And these are all machine learning algorithms.
Thank you, ma'am.
I think I think you understood it.
Any other centers? Sukhmani, Suman, madam.
No, ma'am, there's no any doubt. Thank you very much.
Thank you very much.
Okay.
We will be conducting the valediction now. Are all of you ready for your valediction?
Mulana, okay.
Akhilesh.
Yes, ma'am.
Do you have any doubts, sir?
No, it's all right. Very good, ma'am.
अभी valediction करें.
Now we will have the valediction. वो तो announce कर दिया था मैंने 2-3 बार.
Just
Are you all ready for the valediction?
Yes, ma'am. Yes.
Yes.
All of
Yes,
you?
ma'am.
Okay. We'll have बैठ के हम बैठ के
सामने तो आते नहीं।
अब उधर नहीं आ रहा ना, उधर से
सेंटर्स का वो बताओ।
आ रहा मैसेज पे ही यहाँ से
वहाँ से ऊपर है ना, म्यूट की तरह ये है।
नहीं अब तो यहीं से देखो, वहाँ से तो उनको होगा ना सर।
अच्छा
आप इधर आ जाओ बड़ी चीज।
आपके ये सर्टिफिकेट है?
यार तुम इधर चेहरा पे तो आ जाओ, कैमरे के सामने हो।
प्रीति सबका सर्टिफिकेट है वैसे कोई?
कैमरे के सामने।
अमनदीप, योगेंद्र।
कुछ लोग
जो नहीं है उनको नहीं देना।
हाँ, वही करना है मैंने।
Okay, it was very much interesting for Anthrospin. आया ही नहीं है तो एक दो हफ्ते
इसको काम दिया ना मैंने।
एक दो हफ्ते से मुझे बोल रही थी।
ओके, सेंटर का लिस्ट उधर रखा है। वो जो
अच्छा
देखो
अच्छा हम सकल हैं वो सुने जरा चेक कर। हाँ
Good afternoon to all the participants and the coordinators at the different centers. We have come to the end of the program. Almost all lectures we could do in time itself. So I want to hear the feedback from each of these centers. I'll call you one by one. If you have any guest at your place, your director or any chief guest, they can also speak. The coordinator can speak, and then one or two participants can also give me the feedback how the course is. I would like to hear from you, and any suggestions also I would like to hear, so that we can improve upon more what contents you want more in these courses, or any other courses you want that we should conduct in this ICT mode next year, because now we are planning to prepare the programs for next year. So any of you centers wanted any program, general ones which you want in ICT mode or in contact mode, you can tell me this time. Now we can include that also in our program now, because in the next 2 months we will be busy preparing the next year's plan, because in 2 weeks we have to prepare it. Then all the printing and publishing and all will go. By April 1st week our new year will start, academic year, so that we will start with our short-term courses in different disciplines. So I would like to hear from each one of you. I am calling one by one. Gandhi Academy of Technology, Odisha.
Yes, madam.
Yes. Gandhi Academy, Odisha.
Yes, ma'am. Good afternoon, ma'am.
Good afternoon.
Ma'am, the program was very good. We are very much thankful for NITTR and you also for organizing such kind of events. And our faculty member has learned a lot from this program. And from our side, few problems occur in communication point of view, and rest of the parts were good. And our principal is just coming. He will say something on this. Before that, I introduce some of the a few on this topic. Sir.
Myself, Satya Prakash, ma'am.
I think you can sit and speak. I cannot see your face. Okay. Okay, good. It's okay. Now it's okay.
Principal sir has come. Okay. Myself, Satya Prakash. I'm very grateful that the total lesson is very nice.
Yes.
Two things that I feel I should ask, actually I didn't ask till yesterday. Two things. One is the modularity, and the other thing is uh, reliability attached to these fuzzy and neural network things.
Okay.
I have heard that the two things are never addressed and not supposed to be addressed because we don't have. I mean, the stochastic, the statistical base is not there. There is reliability we cannot attach to these things because there is no. I mean,
You are right.
Statistical
You are
base
right.
is not there.
There is no statistical base. You are right.
so, so how do I mean to implement it into a real life system? Can we, if, in the absence of those statistical base, can we really implement in those systems where some sort of I mean ethics does permit it? So that is a that is a real question beyond technical spectrum. So I actually just thought that this should be addressed at the end.
Actually,
What are
these
the-
are expert systems where these are based on the rules, and then for neural network, when we think of, we have a lot number of data on the previous data. On the base of the data we are doing it. So when that is why we require optimization techniques, hybrid systems, hybrid techniques have come up these days, so that these combinatorial approach will be a better base on it. So that is, you are very right that reliability is a question.
One more thing is like same problem. Once I was submitting a paper, they had asked the same thing, because I showed you in morning one problem where I had used neural network and I have used PSO. They were saying one is neural network is a mathematical method and another PSO is an algorithm there. So we have to just prove that these are different methods and they are giving better results. So statistical tools are also there. Say you have t-test or you have ANOVA, where you can take say real time, you can take continuous data and you can do these tests and you can prove it that whether there is some reliability in the system or not, like whether it is reliable or not. So you can do statistical, like after doing this, you take continuous data and you do some statistical test. Like t-test you can do if there are two parameters, say if you have neural network and PSO you're doing, or you have number of other things, you can go for ANOVA also or MANOVA and you can prove the reliability. That also can be done.
Can be done.
These are the advanced things.
This can also be done if you think that you have a problem of a question of reliability.
You have to prove it. You have to prove it by
Yeah,
some
right.
statistical methods.
Okay, anyone else?
Thank you, madam.
Thank you.
Yes.
Madam, good afternoon.
Which center?
Gate College, madam.
Gate College.
Yes, yes.
Yes, you can speak.
Madam, I just want to give the feedback. Actually, all lectures are very good. Lindy ma'am, Simi ma'am, Rajesh sir explained about applications. They were good, and Simi ma'am explained about simulation were also good. And I hope that they will be beneficial for us.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Now I request principal sir to say a few words on this.
Yes, I want to see. Okay, namaste sir. Okay, namaste sir.
Namaste. Thanks to Dr. M.P. Punya and Lady Matthew ma'am for extending your support and doing this type of activities in our campus.
Okay,
so, second ICT based program, and
yes.
Next also we are going to do another communication skill from next Monday onwards. So thanks for your cooperation. And by this, our faculty members as well as nearby colleges and government colleges, they are getting benefit out of it. Thanks for your cooperation.
Okay. Thank you.
Thank you.
Thank you, sir. Thank you. Okay.
Thank you, madam.
Thank you.
Okay.
Let me go to the next center. Sukhmani Institute of Engineering and Technology, Darabasi. Yes. Hello.
session. We enjoyed and we gained knowledge a lot. Practical knowledge was too good. And our principal sir has arrived. He's saying few words, please.
Hello.
Hello.
Very warm good afternoon to everybody
Thank you, sir.
present at NITTTR and SSIT itself. I myself and on the behalf of SSIT Deravasi express my sincere thanks to Dr. MP Punia, Director NITTR Chandigarh, for choosing SSIT as partner institute and authorized nodal center for this ICT based program, and Dr. Lenny Matthew, the coordinator at NITTR and the coordinator at SSIT, and dignitaries at various centers connected through ICT mode, and the faculty of various centers connected through video conferencing, and faculty of SSIT Deravasi. At the very outset, I very candidly admit that I could not sit all through the technical session of this highly informative and thought-provoking STC of 1 week durations, meant to improve the quality of the technical and vocational education in the country. I sincerely regret the loss of immense knowledge which otherwise I could not have acquired through this rare opportunity provided by NITTTR Chandigarh to the faculty and management of SSIT and other similar institutes of the region. Being keenly interested in continuous upgradation of my knowledge, I try to steal some of my time to attend partly few lectures delivered by highly renowned experts of high repute during this STC through ICT mode. As per the feedback obtained by me from my colleague who attended the full program at SSIT campus through video conferencing, now I feel that I have definitely missed a golden opportunity to enrich myself with the latest uh, pedagogical knowledge and in-depth understanding on the vital theme which covered multi aspects of quality education. I myself and on behalf of SSIT Deravasi extend my unhabited, heartfelt appreciations to Dr. Punia for rare vision and inspiring leadership. Sir, may I congratulate, and ma'am, I congratulate you, your dynamic team, members, institute involved in this exercise for making this technology-based education mission highly successful with a noble purpose to serve. I am sure that program will go in a big way to improve the quality of the teachers, and this in turn will enable the technical institutions of the country to produce good quality and better skilled manpower in abundance to meet the need of the manufacturing sector. Thank you very much, madam.
Thank you, sir. Any participants would like to give the feedback?
Yeah, madam, please.
Hello. Hello.
Hello.
Yes,
Yes,
we can
I
hear.
can hear you.
A very good afternoon to everyone. I just want to say very thank to Dr. Lini Matthew, who was the main coordinator, for inviting such a great personalities over here. Dr. H.K. Sardana, Dr. Rajesh Kumar, Mr. Abhishek Sayal, and Mrs. Shimi S.L. for such a great topics. And it was very interactive session. From Thursday to Friday, it was very interactive session. Uh, for a toolbox, you say, or for research application, you say. We learn a lot, ma'am. Thank you so much. And we will be looking forward for some more from you.
Okay, thank you very much.
Thank you so
Thank
much,
you.
ma'am.
Thank you.
Ma'am,
Anyone else?
yes, ma'am. We have one more participant.
Good, good afternoon, ma'am.
Good afternoon.
First of all, I would like to thank NITTTR for providing us with such a great topic of neural and fuzzy, the FDP. We here at Sukhmani feel really lucky that we were one of the listeners of this FDP. I think all the sessions were quite interactive, and hats off to NITTTR for broadcasting such a clear video of all the sessions, because all the sessions included simulations and graphics, and without the clarity it won't have been possible to attain the knowledge. And moreover, I think the topic neural and fuzzy, it is such a vast topic, such a vast subject, and really it is very good that the teachers there, the presenters, they touched all the corners of the subject, and really hats off to summarize all the corners of the subject in such a short time. Thank you, ma'am. Thank you very much.
Okay. Thank you very much. Anybody else? Okay. Government College for Girls, Gurgaon.
Good afternoon, ma'am.
Good afternoon. Good afternoon. I can hear you. Okay. I cannot hear you. Hello. Now
Very
you.
good afternoon.
Yes.
First of all, I would like to thank Dr. Alini, ma'am, which organized such a course, and we gain a lot of knowledge. We have no knowledge about what about fuzzy logic, neural network, and thank you very much. Here are our staff, Madam Kiran, and HOD our Shri Rajesh is saying something on this.
Thank you, madam, for conducting the very successful workshop in our college. And we request you next time you will organize, give a permission for conducting the simple workshop on role of ICT in teaching, learning like this, so that every faculty member in different discipline can participate in the seminar. Thank you, madam.
Dr. Kiran will say something, ma'am. She is the participant. Dr.
Yes.
Kiran.
Yes.
I'm Kiran Yadav, assistant professor in the college. The course really helped all of us to gain knowledge in basics of this soft computing skills, neural networks, genetic, and also the MATLAB implementation is very much helped me in implementing the algorithms. Like it will help me in implementing the algorithms.
Okay. Thank you. Anybody else?
Okay, ma'am. Thank you once again. Thank you very much.
Thank you. Next, PVP Siddhartha Institute, Vijayawada.
Good afternoon, ma'am.
Good afternoon.
Ma'am, we feel very fortunate to be part of this workshop. All the sessions are very clear and helpful to our faculty in their academics and research. We thank Rajesh sir, who have given a wonderful lecture on optimization algorithms. Really, I have visited his website, vrajeshkumar.wordpress.com. It's really very informative. The people who do research on optimization algorithms, it's mandatory to visit his website. Definitely, they will get so much of information from his website. It's really very informative. And we thank Abhishek Shal for giving a wonderful lecture on where we are using these techniques, where these techniques are implemented in the real world.
Yes.
We thank Sadhana sir for saying how the soft computing techniques are useful in the scientific applications, and we thank Shimi ma'am for giving a wonderful lecture on for implementation of Simulink for neural networks and fuzzy logic. And special thanks to Dr. Lini Matthew for an excellent and detailed presentation on fundamentals of neural networks and fuzzy logic. We extend our deep gratitude to Krishna Prasad sir, who initiated the ICT program in our college. We congratulate the whole team of NITTTR Chandigarh for qualitative and uninterrupted sessions. We look forward for some more workshops in the near future. Thank you, ma'am.
Okay. Anybody else? Speak.
No one.
No. Okay. Next, MC Saxena College, Lucknow. Yes. Hello. We cannot hear you.
Chat box.
You please. We cannot hear you. I think your mic has some problem. We cannot hear you.
सर आप चैट बॉक्स में अपना मैसेज लिख सकते हैं.
आपका मैसेज लिख के भेज दीजिएगा.
मुझे लगता है उनको हमारी भी नहीं आवाज आ
रही. हमारा आवाज आ रहा है.
तो फिर भी बोलिए.
We cannot hear you. I think your mic is giving some problem. you send your feedback in the chat box, message chat box, so that we can read it.
Next center.
Hello, next sender, DIT Dehradun.
Yes, ma'am. Good afternoon, ma'am.
Good afternoon.
Good afternoon. We have our senior faculty, Mr. Bhanu Sarpati with us, and the session was very good. And I would like sir to say a few words.
Good afternoon, ma'am.
Good afternoon.
I'm very thankful to you, ma'am. The workshop you conducted is very nice. It's helpful to us also, and all the topics are covered. It is very advanced, like neural networks and fuzzy toolbox in MATLAB, building genetic algorithms. These are all the topics on which you cover. It is very helpful to us. And ma'am, one thing I want to tell you, while organizing these workshops, it is better for us to conduct in the semester break, because now we have to adjust the classwork and the faculty attending also is less strength. So if you conduct it during the semester break, it will be helpful to us.
Yes.
And also all the tutorial sheets you provide us, we'll try to solve that. If you are having any doubts, we will contact you.
Yes.
Thank you.
Anyone else wants to speak?
No, ma'am. Thank you very much, ma'am.
Thank you. Okay. Next is Engineering College. Mulana, Ambala. Akhilesh, I can see you, but I cannot hear you.
Thank you, ma'am.
Yes.
Good afternoon, ma'am. Myself, Akhilesh Tripathi from Engineering College. Ma'am, really, we are very much lucky. Whenever any course is there at NITTTR, I think I used to be the first person to apply over there. Because of, I am the first person who want to listen always lecture from my Dr. Lini Matthew. Not only this presentation one, I remember those days whenever I was attending my classes with chalk and talk. And you were the first person who told me the impression of the writing words on the boards, nothing to it. So ma'am, anyhow, now the trends, it has been changed. It has come to presentation one. But the lecture which were delivered by chalk and talk, there is no substitute.
Yeah, you're right.
That I learned from you, ma'am. So anyhow, those days, they cannot come back. It's all right. But gold is gold. Number two. Anyhow, it is possible, no doubt, but I will say. Shall I say?
Okay.
Yes. You're listening.
I will be very much thankful if all the lectures, they will be winded in one book. I will accept. Except of editing. What do you get my? Yeah.
Okay. So, I'll write a book.
Yeah. I will keep with me, with my library, because of I am the first person who don't want any editing from your lectures. Yeah.
Okay.
Not only that, ma'am. Actually, I could not prepare your whole video, but I think it is with you. All lectures.
Actually, all these lectures you can listen from Google Hangouts and YouTube's. It is there, already there. The ones you have missed, you can attend. You can go and listen there.
No, ma'am. But thing is that I want with single package. Yeah. Single package, right?
Okay.
No. I will be very much thankful, especially I myself, so that anytime, any doubt, I will take out my CD and get them. And so all the doubts, and future also I can put up my doubts over there.
No, our director is, this year they are planning to have 1,000 videos of all faculties. So even ma'am's package will be there for a particular subject. So every year they are making packages. That will be directly recorded here in a high quality mode. So
And
you will be getting it.
You will get it. It will come.
Of course, you don't have time. That much I know.
No, we will
but
do it.
I will compile. But I will compile. No. But give me this all shortage of that lectures. I will compile by myself.
Mr. Akhilesh, I have a news for you. Mr. Akhilesh Tripathi, I have a news for you. In every of the course, you ask us to have a course in biomedical instrumentation.
Yeah.
On your special demand, this in this O plan, Liniman is planning to have a course on biomedical instrumentation. I think you are the inspiration behind that, because in every course we get a feedback from you. So we are having a biomedical instrumentation.
That's exactly. See, some sentences you very well know, they are common to me. That is all called begging. So I to beg always. That they are common, and your whole team is they know that what else it can come from the class.
We know. You are my student only.
Yeah. That's why I used to beg only, nothing else. Okay. No doubt. So anyhow, ma'am, I will not take much more time. I am very much thankful with the whole programs. With me, my colleagues, Dr. Pava is there. So he want to share some words. Thank you.
Good afternoon.
Namaste, sir. I have met you, Papa, sir.
Madam, the lecture given by you on neural network and fuzzy logics are very wonderful. We have learned a lot of things from that lectures, and the practical things explained by Madam Shimi on the Simulink. We expected very depth knowledge, but almost all the lecture is on electrical system. So we are from electronics, so we are not learning that power system. We request that some practicals on Simulink regarding electronics should be there.
Actually, our electronics department is also working on MATLAB, Garima madam वगैरह communications में MATLAB में काम करता है. I hope that they will be able to do justice. We are not very versed with electronic subjects like communication and all. That must be the reason why you felt like that. I hope the electronics department may be able to do justice to your requirement. I will tell them. Okay, sir.
Okay, thank you, ma'am.
Anybody else?
Thank you, ma'am. Thank you, ma'am.
Okay.
Good day.
Now I have a request to all the centers that you please send the list of participants and the list of students who had attended the program separately, and also your bills as soon as possible, because it is March coming up, and they have to process the bills also. So if you send it fast, the bills also will be processed fast. So I request all of you to send the list, and the list in that Excel sheet format which I think Gandhi Academy or the new colleges which you have joined this time, I will send you the format. Otherwise the other colleges like DIT and Engineering College, PVP, they know how to send the list of the participants, so, and the bills also. So I would request all of you to do it in time in the next week itself, so that it will take time at our side also to type all the certificates and send it and things like that. So you send your things fast. Okay. Now we'll come to these participants in this sender. You can speak now. What is your feedback about it? Any suggestions? Any new courses which we want to do?
Overall, the course was very good, but I would like to suggest some courses on finite element mathematics. That is for the designing of electrical machines.
हमें खुद वो नहीं पता.
That's not our area of expertise.
Actually, one thing we can do is we will our lectures, like say machines or something. Machines also, ma'am is conducting. So we'll call experts. Like we'll have special lectures.
This year
on
we
that.
have put a course on finite advanced electrical machines.
Incorporate कर सकते हो.
So उसमें एक lecture कुछ हम भी शुरू कर लेते हैं. COMSOL physics and all we don't.
Yes, that will be. Yeah, you can suggest so that we can call,
because
so we want experts. That is what
we are also planning to take COMSOL physics also. Let us see next year we will take, so that ये finite element method है ना, it must be a good area of research at our place also.
We will try to do.
We will try to do it.
Because this time we have kept machines में एक दो lectures call करके.
Yes. Trend है उसमें.
We'll do that.
Madam, Anu Singh.
No, it was very informative course. And one exclusive course for power system can be also designed and also programming applications of power system.
Earlier we used to have a course on computer-aided power system analysis.
No one used
but slowly no participants became. So that's why we discarded that. We had computer-aided power system analysis.
2 साल चला आया, कोई आया नहीं पर हमने इस बारी का.
There were no takers for that.
Actually, we are having a course on facts and
Many other.
we are doing a next year. This year also we did a course on facts and smart grid. In that we do little bit of MATLAB and all contact mode में smart उसमें नहीं है. So see whether we can do something because
We will
power
see that we
system
will call some power system people itself, those who have worked with this. We will try to enroll, like even Ashwini Kumar sir, we can call and we can have some special.
But then they all will speak only the
Only the
distributed
base,
generation and basics and all. जो आप जो power system implementation MATLAB करते हैं वो हम ही करते हैं. So let us see.
We will see. We will try to identify some people, and if you know someone, you can tell so that we will also call them here.
So what do you say that we advertise the computer-aided power system analysis again this year?
Ma'am, yes, you can do it, or you can say if you have a problem of the power systems and all, then renewable energy like power generation can be a core theme that then power system.
Smart grid and renewable, we have a course.
That's an ICT.
ICT.
Smart grid and distributed generation.
Smart grid and distribution generation we have.
ICT
So in that we
program.
will try to include, and if you have some experts, you can just share with us who can like.
Implementation कैसे करेंगे? How will we do that? बच्चे, mic off. Mic off.